Hey friends, I'm Scott.
And I'm Kendra.
And we're going to learn about C#. This is our C# 101 series. But before we even start talking about languages and syntax, we have to ask ourselves, why C#? Like, what can I do with it?
Yeah, choosing a language is really important. And one of the things I love most about C# is the beautiful syntax. It's all about that syntactic sugar. So you don't need to understand everything about the language right now. But when you want to scale up your designs and create some great architecture, C# is a good choice for that.
Definitely. You don't have to memorize all the little details right now. And you also have a whole ecosystem that you can use. So if you find something that you want to do in C#, you can probably do it. I mean, what can I build with C#?
Definitely. So you might just be making a website or a console app right now, but if you want to scale that up sometime in the future, take it mobile, go AI, use machine learning, something like that, C# can grow with you.
Yeah, it's one language for lots of things, whether it's a Raspberry Pi or an Xbox game or a website or just a little console app that prints out some text. There are really no limits to what you can do with C#, and we're going to walk you through those things today.
Right. So this tutorial is going to go through web browser, C# language features, and then we'll graduate into using Visual Studio to actually compile C# on your machine.
So let's start with Hello World in the browser right now. Hey friends, we're learning about C# 101, and this is our Hello World video. You may have seen other video tutorials using Visual Studio for their code, but we're going to try something different, and we're going to do it in the browser. So what I want you to do is go to your browser and go to docs.microsoft.com, that's documentation for Microsoft, and click in Search. And we're going to type in C# tutorial. Go directly to the C# tutorial. And these are a series of tutorials, and we're going to walk through all of these today. We're going to go to Hello World, and it brings you to an interactive tutorial page. And when we hit Begin, over on the right-hand side, it says you can try the code in your browser. So I'm going to click Enter Focus Mode.
So as soon as you enter focus mode, an editor appears on the right-hand side of your browser. In this editor, you can actually execute the C# code that's on the left side. So if you go ahead and copy the console.writeline statement into the .NET editor.
Okay, and I'm going to hit Control-V to paste.
Nice. And you hit the Run button on the right side. It can actually run that C#.
Now, does C# run in the browser? Is that a thing I'm going to see in the world?
So for this tutorial, yes. And we are working on a product called Blazor, which is actually C# that executes with WebAssembly.
Cool. So C# does run everywhere.
Yeah.
So I said console.writeline. What's a console?
So the console is what you can use to output strings, and you see the output window right below. So everything that you put in those little quotation marks, which currently say hello world, is what's going to appear in your output.
So I can change that, and I'll say hello friends, and hit run again. And now I've changed and run my C# program one more time.
Yes. Right, so that's the simplest C# app, my first program that you can run in your browser. No setup required.
You have done it. You can put programmer on your resume now.
Yay!
So let's hit next and see what's next in our tutorial. So when you make a Hello World application, you have to think about variables, right? Now in this case, we've got hello friends inside of console.writeline, but we haven't declared any variables. You hear that term a lot when you're programming.
Yes, so right now it has you declaring a string, a friend variable, and that name is Bill.
Okay, so I'm going to go and copy over the top of that console.writeline. I'm going to delete that. I'm going to paste in this new one. It's console.writeline again, and I'll put in Kendra, and I'll hit run, and now it says your name.
My name, Kendra.
So Kendra lives in the variable called a friend, and then I can use that as many times as I want.
So now let's change the variable again to say Scott.
Okay.
And when we run it as well, it now prints Scott's name. Next, we want to append hello to the beginning of the write line.
All right, so I'll come down here and I'll say console.writeline. Where I output a friend, I'm actually going to say hello. I'll put a space because I want a space between hello and Scott. I'll say plus and then a friend. So we're going to say hello, which is a string on its own, plus a friend, which we know right now says Scott. When I hit run, that works as well. So we've gone and just put two strings together, a string here and then a variable with a string inside of it. Now the next thing that we can do, which makes things a little easier, is a thing called string interpolation. Instead of saying hello plus Scott, maybe we could say it a little differently. I could say hello, a friend, and I'll put a friend inside these curly braces. Sometimes people call them mustaches. Now, why has this got a little squiggly here?
I think that's because it's not valid C#. So it looks like in the example we have a little $ symbol.
Right.
Now that actually signifies string interpolation is being used. So a friend, it will recognize as a variable. And make sure you add your ending quotation marks as well.
So I've got an opening quote and an ending quote. I've got an opening parentheses and an ending parentheses. I also used my $ like you said. And now a friend is our variable, and I hit run. And it says, hello, Scott. And for really long sentences, that's a lot easier than saying hello plus Scott plus last name plus this and that.
Yeah, it's another tip of how C# can be really simple to read. So in this video, we went through Hello World. We made it a little bit more complicated by using variables and appending different strings. And in the next video, we're going to dive a little bit more into strings. In our last tutorial, we covered Hello World. Now we're going to talk a little bit more about strings. So how do you think of strings?
Yeah, we said strings a lot. You hear that in programming. Oh, we got to string this, and attach this string to this other string. I think about it like friendship bracelets. Remember when you go, you make your friendship bracelet, and you string these different letters together. You take characters with your name, you put them onto the string, and then you get a friendship bracelet that says Kendra or says Scott.
Yeah.
That's how I think of strings.
And the little ties at the end can be the quotation marks.
I didn't even think about that.
I like
yes,
it.
the little knots at the end are the quotation marks. That's a really great way to think about strings. So we're going
right.
to talk about strings right now. So we'll switch back over to where we left off in Docs. When you last saw us, we were doing step 2 of 7 inside of docs.microsoft.com. I'm going to hit next, and we're going to work with strings. Before we had said there was a variable called a friend, and we said hello, a friend. But here we have something more interesting. We have 2 friends now, first and second. So I'll hit copy, and I'm going to paste over the top with, again, Control V, and I'll say Scott and Kendra, and I'll hit run again. All right.
Cool. So here we actually were able to use 2 interpolated strings. So first friend is the first variable that we declare as Scott, and second friend is the second variable that we declare as Kendra. And you can see in our output on the bottom that my friends are Scott and Kendra.
And these are strings with names. They're variables. First friend is the names string, and second friend is a string with a name. And then this string inside of console.writeLine is also a string. It just doesn't have a name. It's literally a string. And sometimes you'll hear people call that a string literal.
Oh, yeah.
Yeah. And then we have the little $ in there. The $ is kind of cool. It makes it magic. You said that word, interpolated. I don't know what interpolated really means, but I do know that if I remove the $, it breaks my code. And if I go and say run, it'll just say, look what it does. It literally shows the string literal. But if I add back the $, suddenly that string means a lot more.
Definitely. So strings can also have a lot of different properties on them. So in our next example, we actually access the length property, and that's going to tell us how many characters are contained in this string.
So I'm going to copy that example, and I'll come over here, and I can add on to that. So I'm going to keep the first code that I copied from before. I'm going to add this code at the bottom, and you'll see, as Kendra just pointed out, first friend is our string, and .length is a property of our string. So let's hit run and see what that says. There we go. The name Scott has 5 letters. The name Kendra has 6 letters. Cool. And it's also worth pointing out that if I maybe mistyped that, if I typed in something that's not length, not only am I going to get a squiggly, kind of like when you get a spelling error in Word, but when I hit run, it's going to tell you, oh, I don't know what length is. Length. We have no length here.
That's not a property on a string.
Silly. It's length. And then we hit run, and then we come back, and it works.
Cool.
Cool. Let's move to the next step and learn more about strings. So sometimes strings have leading or trailing spaces. That's an interesting one. Do you want to delete all of this code and replace it with this code?
Yeah, let's start over with a clean slate.
Okay, so I'm going to go and select all of that text there, and I'll hit delete or backspace, and then I'll paste in this text. And look at this string up here. What's going on here?
So yeah, it looks like it has an extra tab or a bunch of extra spaces.
Yeah, they call that
before
white
and after
space.
Hello World.
Yeah. I don't want that white space. And if I go and say run, oh, this is interesting. Look what happened here. They put a little square bracket. I could put even stars if I want to. I could say star, 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 or just some character. And they're doing that to show us a way to visualize the white space.
Yeah, so where it actually started and ended.
So there's nothing special about the bracket in this example. It's just them saying, here's a character that you'll recognize, and then your string that you want, and then another character that you'll recognize. So we can visualize that space. And then here on the next line, on line 4, we're going to say, hey, let's take the string called greeting and let's trim it. Let's just chop off. So what are we trimming? Are we trimming a number of things? No, we're trimming the white space. So we have trim start, trim end, and then trim. Just trim
So
generally.
just trim.
Yeah.
Trims all of it.
Right. So this is kind of interesting. It shows us that white space or spaces, and you said tabs, are a thing, that they really matter. Like white space and spaces matter. So sometimes you need to think about that when you're dealing with strings.
Definitely. So this can help you better format the string before you output it.
Now, strings have length, we talked about before. They have methods. In this case, we're actually calling a method. See how we said trim start, and then we had parentheses. The parentheses indicate that it's
A method,
right?
yeah.
If I get rid of those parentheses and I try to run it, it's going to say, I don't know what that is. That's not a thing. If I put that back and I hit run, now it works,
Yeah.
right? And if I said dot length, that's not a method, that's a property. So we have to keep track of those things when we're doing this work. Here's another useful method of a string. Replace. Let's try that. So we'll paste that in.
Yeah.
Hello world.
So here it looks like we have a string that says hello world, and we want to write it out before we do anything with it.
Okay, so we'll
So
write
we
it
have
out
that
right
console.writeLine,
Right,
and
and
then the
actually-
next place.
I'll cheat and I'll do it right now.
Oh yeah,
Okay.
so that's what it looks like before we do anything with it.
Okay.
Now let's call this sayhello.replace. So we're taking the say hello string and we're replacing part of it, let's say the hello, with it should be greetings.
Okay,
So let's go ahead and write that again.
all right. Aha, so we said hello world, which was inside of say hello. We output it, that's that first line. And now we're saying, this is really interesting here, look. It said say hello equals say hello again, dot replace. So when we replace that string, I kind of imagine another string shooting out of the back of this one, and now we've changed say hello. So this variable, say hello, has different stuff in it now.
Yeah, and the calling replace on it actually searched for where hello exists in the original string and replaced it with greetings.
Exactly. And if I change that, I can say hello world becomes Kendra,
Kendra
world.
world.
Right?
Ooh, I like the sound of that.
Yeah. So we can manipulate these strings, and again, the result of that replace comes out. We can see that again if we go and try these variables. If you want to make something maybe all caps or lowercase, let's go and take these lines here, and at the end of Kendra world, we'll go and say console.writeLine again, and we're passing in say hello to upper and say hello to lower. So I think I know what's going to happen when we hit run. Ah,
Ooh, so the first one's shouting.
yep. And
'Cause
that
it
one's
changed it to all
low
caps.
key. That'll be your album cover title there, the low-key, lowercase Kendra world. So this is interesting because we didn't actually change say hello. We didn't assign it to a variable. We didn't say hello equals say hello to upper. We just kind of changed it in place.
Right. So if you actually did a console.writeLine again for just say
that's a
hello
great point. Let's do
and
that.
print that out, you'll notice that say hello wasn't permanently changed. So it still has the capitalization that it had in the beginning.
That's a great point. So here we can go and see the state of our variable. And sometimes when you're just getting started, you're going to find yourself, console.writelining a lot, just to know what's really going on with your variables, which is cool. Wow, that's a lot.
Yeah.
So we've learned a little bit about strings. Let's take a breather, and then we'll go to the next video, and we'll get deeper into strings in C#.
So we just learned about string basics, two upper, two lower, trimming it a little bit. Let's talk more about searching strings.
When you have a string, you might want to see if it has something in it. You might want to search that string to see if the string, your friendship bracelet, contains another string. So let's go and do this. I'm going to go ahead and get rid of Kendra World, sorry. And I'm going to paste in our song lyric here. You say goodbye and I say hello. We can ask ourselves, do these song lyrics contain the word goodbye? And do these song lyrics contain the word greetings? So let's run that.
True and false are what it outputs.
Where did that
So
string come from?
I suspect that the first output was the result of the first console.writeLine. So what you have highlighted there, song lyrics.contains, it actually returned true because goodbye is indeed present in our string. But the second one, where it searches for greetings, it returns false. So what if we changed goodbye to greetings in the original string?
Oh, good point. Let's do that. You say greetings, and I say hello. I'm glad that that's not how the song went.
Yeah,
We'll
that'd
hit
be.
run. Let's watch the output real quick. I'm going to hit run. It's swapped.
So now it's swapped because it can now find greetings and it can't find goodbye in that string.
Now, sometimes it can be a little confusing because we're saying console.writeLine and there's a function inside it. So we're doing a kind of a method within a method. I'm actually going to do something just to make a point, and I'm going to just cut that. And I'm going to say variable result equals, and then we'll say put result inside here. And this is just a reminder because we're talking about variables. We talked about strings. We talked about numbers a little bit. Here, that true or false comes out and lives inside of there, doesn't it? So if I hit run, I don't think it changes.
No, it doesn't. So it's still storing the same result that you get when you execute that small bit of code, that .contain statement, but it's storing it in results, and then your WriteLine is writing it.
And those are called Booleans. Boolean just means true or false, and then we'll learn more about those a little bit later. So you've got contains, and then you've also got things like starts with and ends with that you can ask as well. So I could say starts with goodbye. I know that it doesn't start with goodbye, but it does start with you. So now I have true
Now
and
you
true.
have true.
So you can play around with strings and learn all kinds of things and ask questions of strings to figure out what your strings contain, what they start with, and you can manipulate strings as well. All right, so you've made it all the way to the end of strings. We're learning about strings.
Yeah. So in the next video, we're going to cover numbers in C#. So we just finished the section on working with strings. Now we're going to take a look at integer math.
So I'm going to go back to my documentation site. You can see I've just completed the Hello World introduction. If you haven't, you should make sure that you go back and take a look at those videos and complete that tutorial yourself. We're going to move forward to numbers. This looks scary, manipulating integral and floating point numbers in C#.
It's not scary.
All right, I appreciate that.
Let's go ahead and begin.
So we'll hit begin. Remember to click on focus mode so that you can get your editor there. So
Great. So here we have a list of integers declared in C#. Let's go ahead and copy that into our editor. At the very end, we have a console.writeLine for C. So it looks like C is being calculated with the two integers above it, A and B, A being 18 and B being 6. So when those two are added together, that's how we define C. We get 24, and then we output that.
And that's also a nice reminder that console.writeLine can take strings and integers and all kinds of types. If you ever have a question, just console.writeLine it to see what's going on.
Right. And we mentioned integers, so you're going to be seeing a lot of integers. It's one of the fundamental math types in C#. So it represents an integer or a positive or negative whole number.
And we can apply, in this case, plus or addition, but we can also do subtraction, multiplication, division to these things as well. So I might go and just change line 3 and do something different, like times. So here we'll go and multiply them, and now it's not 24, it's 108.
108, which I totally expected because I did that in my head. So let's try out division.
All right.
So 18 divided by 6 is 3.
All right. So that works great. And of course, you can do multiple operations in the same line, but then you have to start thinking about order of operations.
Yeah.
So let's move next to the order of operations tutorial.
So many of you might remember the order of operations from math class. So basically, multiplication and division take place before addition and subtraction, that kind of thing. We reflect a lot of that in C#. So let's take a look at our examples. We have A plus B times C. So A and B are 4, and B times C, or C is 2.
So B times C is 4 times 2, and just like the order of operations in the math that you're used to, C# behaves the same way. So B times C, 4 times 2 is 8, plus 5 is 13. another way to look at this is that C# behaves the way you would expect it to when it comes to math.
Right, so if you're working this out on paper, it's the same thing that the order of execution would be the same in C#.
Right, but what if I want 5 and 4 to be added together? I can put parentheses around them or brackets around them and hit run. I'll get a different output because parentheses come first.
Makes sense.
Now look at this one. I could do all kinds of complicated stuff, mixing variables and numbers and order of operations all at the same time. Can you do that in your head? I cannot.
I would prefer not to,
I would prefer
but
not to. I would prefer not to because I have a computer for that.
exactly.
And there you go.
So everything in the parentheses were first and then followed by multiplication, division, and addition and subtraction.
Now, one interesting thing that happens that we'll talk about a little bit later is you might expect fractions or decimals or pieces of something if you do a division. Like here, we'll go and we'll say 7 plus 4 is 11 divided by 3. 11 divided by 3, that doesn't really...
So we know that won't come out to a whole number.
Yeah, will it? Well, hang on. 11 divided by... That doesn't seem right at all. So what's
No.
going on there? Integer division always produces an integer result. And that's kind of interesting. It's only giving you the whole part.
So the fact that my d variable is actually an integer, which, as we know, integers have to be a whole number, it now forces that result to be a whole number.
Exactly, because we basically shoved it into that. We boxed it into a variable called int. So int plus int divided by int is always int. And in this case, we lost information. So that's something for us to think about in another video.
So we just took a look at dividing integers and getting whole numbers, other integers out of that.
I want the remainder. I don't know where my remainder is. I won't be able to sleep until I know what 11 divided by 3 is.
Let's look at that in the next video, looking at precise integers.
Hey friends, in our last video, we talked about numbers and integers. And now we're going to talk about integer precision because, you know, earlier we divided 11 by 3 and we got the number 3 and that kind of upsets me.
Right.
I want to know where my remainder is. So we're moving on to the next bit of the tutorial, which is integer precision. And they told me that it truncated the result.
Truncated. Now that's a vocab word. That basically just means we lost the remainder.
Okay, so
on
it's
the result.
gone, which is sad. But what we're going to do is we're going to use a different operator, not the division operator, but we're going to use the modulo operator. So in E, I should get my remainder. Okay, so it's 11 divided by 3. The remainder in this case is 2 because 9 divided by 3 is divides evenly. The remainder is 2. So that's interesting. That didn't give me a decimal or a fraction. It gave me the quotient and the remainder.
Right. Just as if you had worked it out by hand, the remainder would have been 2 at the end.
Now in math, though, integers can kind of go infinitely, though, right? But in C#,
Right.
there's a minimum and a maximum size for an integer.
Oh, okay. And that's just limited to how much the computer can actually keep in memory in this value type. Because as we said before, integers actually do have constraints when you put them into a computer. So with math on paper, it can often be very theoretical. When you write it down, I could have just an infinite number. With computers, we have real world constraints for how much we can actually save into this processor.
Okay, so let's go and copy this sample and say int.maxValue. Just like we said string.length, it had a property. Integers have properties as well, like min value and max value. And then we'll do the same string stuff that we did in a previous video, and we'll say, let's see the min and the max.
Yeah. Wow.
Oh my
so
goodness.
It's a pretty big number.
Looks like
see.
negative 2 billion.
About that?
Yeah.
Sounds about right.
Yep, 2 billion and a couple of 100 million.
Right.
Between friends. And it's interesting, it's negative to positive, right? So it's it's a
Right.
4 billion wide range. And but what if we maybe added 3 to the
Ooh,
max?
yeah. Let's see
take
what
max.
happens.
So we have 2 billion, 147 million, and we're going to add 3 to it. Well, that's definitely weird. We said max value plus 3. It flipped the odometer.
Oh, so now instead of going the last few numbers are 647, so it could have gone to 650, it actually just
Right.
became negative.
So this addition operation overflowed. It's like when you have an old-timey odometer where it goes all the way to 0 and then
Oh.
keeps going.
It just flipped over.
So it
yeah.
wrapped. We were on max, like to be clear. We were at the maximum number, which is super high, and now we're at a super tiny number. So something you want to think about when you're dealing with numbers that are really, really huge. And maybe there are other types with different limits that might be bigger, like
Yeah.
instead of an integer, a long, or something like that.
Yeah, so you can definitely use larger numbers. It's just at the get-go, you have to make sure you tell your computer that you're going to go above the integer max. So you might want to use a long in that case.
So let's go to the next one. So a numeric type that lets you do a really big number would be a double. And doubles are cool, not just because they're giant, but they're also precise, right? They let you do things with decimal points. And so far, we haven't seen any
boy.
decimals yet, right? So let's do the exact same thing, right?
So doubles. There we go. There's
now we're
our
talking.
remainder. We got 4.5.
Right, and that's a little bit more intuitive. It includes the decimal point. So I didn't have to go and do that modulo stuff, which I found a little bit frustrating. Let's try a more complicated example with doubles. There we go, 5.25. That's good. So like, what is a double min value and max value?
Oh, yeah.
Is it going to be 2 billion? I don't know. Holy crap.
Oh, wow. So we've got e to the
308 power or whatever.
yeah,
like-
so much, much larger than
That's-
what integers were limited
Right.
at.
So that is scientific notation, and that number to the right is not, that's to the power of, as a power of 10, as an expression as a power of 10. So basically, a lot more, to put it in
So
technical
much more
terms.
it needs to be printed out in scientific notation. Cool.
And this is an interesting one, too, that you want to think about, because decimals and fractions are slightly different. So if I divide 1 by 3, you'd expect I would get 1/3. But instead I get 0.33333333, which is not exactly the same as 1/3, but it's close. It's repeating.
Yeah, it's another case where if you had it on paper, the theory of math is a lot more exact. But again, computers are in the real world, so it has to have some concrete representation of this number, which means ultimately it's rounded at the, 12th decimal place or something like that.
Right. So we've talked about small numbers like integers and really big numbers like doubles. Let's take a break and we'll come back and talk about another kind of number in C#.
So we just went over the basic types of some math in C#, integers and doubles. Next we're going to talk about decimals.
So I'll switch back over here and I'll go to next. It says working with fixed point types. We talked about integers, which don't have anything after the decimal point. And we talked about doubles, which are huge. They go off into space with all kinds of information. But there's one other type, the decimal type.
Right, so this one has a smaller range, but much greater precision than the double. So the term fixed point is just a decimal or binary point that doesn't move. So let's go ahead and copy in their example into our .NET editing window.
Okay, so we're going to look at the min and max of decimal. Whoa. So that's interesting. That one is really, really, really long and goes forever in 2 directions. So it's got a very, very wide range.
Right,
But
we
not as much as the double.
Right, because we didn't actually need scientific notation to represent how long the range was.
That's a good point.
But it is larger than the integer.
I don't know what that is. It's a gabillion or a quintillion?
You know, I don't know.
I have no idea.
but we
let's-
don't need to.
Yeah, but let's see if we can do some stuff that we couldn't do before. Remember when we did our double, we got 0.33333.
Right.
Now we're going to say decimal. So I'm going to hit copy, and let's put those over here. So we're going to do the same exact thing, 1 divided by 3, with 2 different types. Ah, look at that. You do get a lot more precision. You get a lot more numbers there. And notice also something special here, that M that got added at the end there. When we said, hey, this is the number 1, we added an M that treats it as a decimal. And there's a bunch of little suffixes like that that you can go and learn about. But there's a lot more math than just what we're talking about.
But there were some other types that we also mentioned, like longs, that have max values as well. Do we want to actually put all of those in our .NET editor and see how all of the max values compare across different C# numeric types?
That is a good idea. So I'm going to go and grab decimal, and I'm going to copy paste, and I'm going to make that int and int. And I can't use the word min multiple times, right? So I'm going to say min2, which is kind of silly. And we'll say the range of int is min2 to max2, all right?
Right.
And then let's do the exact same thing. You said a long?
Yeah.
Yeah, I don't know how big a long is. It's going to be bigger. I think it's bigger than an int, though. So let's say a long, and we'll say long. Now, this is going to be a good reason to move over to a fancier editor because I feel like I want to do a little bit of search and replace here.
Oh, yeah.
But my web-based editor is limiting me in a little bit. So there we go. So let's go max 3. So we've got decimals, integers, and longs. Decimals, integers, and longs.
Okay, so that makes it really easy to compare them.
And they do have very different characteristics, right? Int is the one that we would use the most. Now, why wouldn't I just use the biggest one all the time?
So I believe this takes up, so certain numeric types will take up more memory in C#. So the computer is getting ready to receive a really, really large value. But if you aren't actually going to be using all that space, you might want to use a type that doesn't reserve as much.
Right, exactly. So you hear the term about like 16 bits or 32 bits or 64 bits. Like if I had a million numbers, but they never got really large, they're just a million small numbers,
Right.
I would probably use something really small. We also have a thing called a short as well. So there's longs and then there's shorts. So you just really want to pick the number that makes you happy. But for starting programmers, wouldn't you say it's a fair statement that an integer will usually do what you need it to do?
Definitely. As long as you're not getting into anything that needs a decimal, I think integers are probably going to be fine.
Yeah, yeah. And the fun part about this and about these videos is learning the different types and that they do exist. And the great part is that you can always go and search for it and learn more and see how tiny, oops, I just said a long type. Let's say a short type.
There we
Look
go.
how small shorts are.
Oh, so tiny.
Yeah.
Cool. So let's take all this knowledge and put it together to find the area of a circle.
All right. So let's go next because I'm going to cheat and see the answer of the challenge. See if you, well, you can do the challenge yourself, but I'm going to go and take the code of the challenge. And this is to determine the radius of a circle. And this is interesting because it's saying math.pi. We don't actually have the symbol pi. There's actually a class called math, and it has a property called pi.
I definitely wouldn't like to type the keyboard combination that would get you the pi symbol. So I'm glad we just have math.pi as a constant.
Yeah, and there's actually a bunch of stuff that hangs off of math. You can see
yeah.
e
Log 10.
and pi and log. So not just min and max. So let's go and figure out the circle. There we go, 19.63. So it's pi times the radius, and in this
Squared.
case, squared. All right. I didn't really do the challenge, but at least I ran it and I feel good about myself.
Right, at least you see what it looks like. So we just covered all of the numeric types in, well, most of the basic numeric types in C#. And in the next tutorial, we're going to go over branches and loops.
Hey friends, we just learned about numbers in C#, and we're going to go into branches. That's like if statements to do what they call conditionals. And we were going to go and do that inside of the browser like we've been doing. But you made the suggestion that maybe it's time to graduate.
Right, at a certain point you want to start using Visual Studio because even when we were in our browser, we were getting little errors and squiggles and warnings, but in Visual Studio, you're actually going to get even more hints and code fixes to help you out, and it's just a lot more feedback. So let's talk a little bit about branches.
Before we do that real quick, I'm just going to go to visualstudio.com/free. And this is a
Ooh.
URL that lets you get a free version of Visual Studio. It's totally free. It's called Visual Studio Community. And it's got all the power of the Visual Studio that programmers use, because you're a programmer as well. You can download that for Windows or for Mac and enjoy that. So I've installed that already.
Okay.
And then I want to point out that here I'm in the in-browser experience, and I could continue into branches and loops, which you're certainly welcome to do. Or if you look in your tree over here, there's a section that says work in your local environment, and we're going to do that. So we're here on this page, learn conditional logic. We'll make sure we have links to all of that. So we're going to do this. We're going to run Visual Studio and follow along, copying not into an in-browser code environment, but rather copying into Visual Studio directly. Is that
Right,
cool with
and
you?
we can get all of that feedback. Yeah.
Okay, so I'll run Visual Studio, and that's going to come up, and I get a page that's going to look something like this. Yours will probably be blank, because you can see me making applications.
Right, if it's a completely fresh install.
So what should I do?
I think we should go ahead and create a new project, and we'll just work out of that. So we want to choose the .NET Core Console app. I'm not going to go into explaining those terms. Basically, it's just C#. Console apps are kind of your basic command line applications that print output in a terminal window when you run them.
Right. Well, we've been
That's all you
saying
really need to know.
console.writeline. It's like that black box that pops up. So we're going to make a
Right.
console app. And in the future, in other videos, we'll make web apps and different things like that. So I'm going to go and say new console app. And this is where we will learn about branching, right? Mm-hmm. Okay. So already I'm like, what's happening?
Yeah, what is all this stuff?
Are there going to be videos that will explain kind of the menus and what's going on in Visual Studio?
We'll go around and so that console.writeline, that's the only part of this that we're familiar with from past videos. Everything above it, the static main, string array, args, all, class program, all of that, we can get into in a different video.
Okay, so we will talk about that, but for now, pretend that we live only in between these two mustaches.
Yes,
Or
curly braces or
curly hats.
mustaches, whatever you want to call them.
See, now mustaches is not inclusive.
It isn't?
I don't know.
I can have a curly brace.
Touche. So here we've got our console app, and what I'm going to do is hit play, but what I like to do is start without debugging, and this is just a hotkey I remember. This is the only hotkey I'm going to ask everyone to remember. I'm going to hit Control F5. Control F5. And this is nice because this lets me run my application. So this is doing the exact same thing as hitting that run button.
Ah, yeah.
And it
and
says,
this black box is
Hello
the
world.
output window.
This is
The
console.
same as what we saw. Oh,
Yeah. Now, certainly, if you don't want to do that, you can just hit this green button, the run button. Okay, so console.writeline, hello world. Again, Control F5. Cool, it worked. Now, how do we do branches and loops? Well, this is going to be a tutorial, and what I could do if I wanted to is I could pick it up and I could snap it off to the side here, and then I could have Visual Studio on the other side. We could try this and see if this works out, and you could try the same thing. So I'm walking through the tutorial, and you see how I can just move the splitter over just a little bit so I can see what's going on here. So if statements let you make decisions. The tutorial will tell you to go and create directories and run things at the command line, but since we're using Visual Studio and we just made a new console app, we don't need to do that stuff. We're just going to put our code right here.
Right, so let's input our first if statement.
Okay.
So it looks like we declared a few variables that we can then use as part of the conditions inside of the if statement.
So I'm going to hit copy, and then just as before, I'm going to hit paste. Hey, that's cool. Visual Studio actually put it in a nice location, and it's all got coloring. If is colored a certain color. This looks really nice. It's kind of pleasant looking here. Will it work right off the bat?
Let's try it.
Okay, so I'm going to hit Control F5 again, which is again the hotkey for hitting the play button. The answer is greater than 10. Let's put that next to this here.
And what exactly were the conditions we were using in that if statement?
Well, we took A and B and we added them, and A plus B is 11.
Right, so 11 is greater than 10, so it did execute the console.writeline that was within that if statement branch.
Okay, and if I change that and I make it 5 plus 3.
Ooh, so that would be less than 10.
It didn't
And
really
it
do
didn't
anything.
print anything.
Yeah, just said, "Meow," and then told me some things about how the application exited. So that shows us that if statement in fact worked. So in this case, the sum was less than 10.
Right, so if the conditions weren't met, it doesn't actually execute the console.writeline that's within the if statement.
Right.
And yeah,
We had talked about Booleans before. Remember when we said, does this string contain this? Or does this string start with that? Is that a Boolean?
yeah, so any kind of if statement will need to return true or false as the ultimate condition to decide whether or not it will execute any of the code within that if statement block.
Right. So I could go and say bool something equals that thing. And I have to say a semicolon at the end there. And I could say if something.
Right, so
Will that
that's
work?
like independently declaring the Boolean outside of the if statement.
Let's see if it works. It does work. So whether I put it inside here or outside there, the fact that it's true or not, it doesn't matter. And now I'm going to hit Control Z, which is undo. See, look, and I just hit undo, and there's a button here for undo as well. So that let me know that that actually worked. So what about the else? Remember when we said it was smaller than 10, nothing really happened. Like it just stopped.
Right. So else would be if there's any kind of condition that we should do when the if statement condition isn't met. So basically, instead of just not writing anything, we could put in an else statement to say, hey, this answer is not greater than 10.
Okay, so if the sum is greater than 10, else do the other thing. Cool. Let's try that with a small number. So here it's going to be 8. Again, I'm going to hit Control F5, or I can hit the play button.
The answer is not greater than 10. So it executed anything that was in that else block since the if statement wasn't met.
Right. And it says here, any key to close this window. I just hit space or any key. And this is interesting. I was actually going to ask you this, Kendra, because I was a little confused. Does it matter that this is indented? Like, can this be over here or over there? And what if I have other lines?
Yeah, so in this case, if you ever want to have multi-line if statements, you need to add curly braces. As far as the white space trailing before and after if statements, that means indentation or extra new line characters and stuff. I believe an if statement will execute the single statement after it if there's no curly braces.
Right. And Visual Studio is smart about
try
this.
it,
If you
though.
get confused, you can just say format document, and Visual Studio will make it better.
Ooh.
But yeah, let's try that actually. Let's put that on one line. Let's put that on a line. That's kind of weird. That's not usually how you do things, but
Yeah.
I bet you that it'll work. It does.
Cool.
But the right thing to do, I'm hearing you say, is when all else fails and there's a question, just like order of operations,
Right.
always add an extra parentheses. It never hurts to add those braces. And it's cool. Look, Visual Studio is actually lighting them up. So if I click on one of them, its friend turns color.
Is highlighted a little bit. That's another one of the benefits that working in an actual integrated development environment over a browser can provide. So you have brace matching.
Yeah, that's a
pretty
good
nice.
reason for us to go and upgrade right there. Just one of the many reasons. Let's try a complicated if statement.
Oh yeah, so this looks like it will have multiple conditions inside of it.
So I'm just going to copy it and paste it. And by the way, I just noticed that when there was nothing there, these turned gray, saying they're not really used.
Oh, it's assigned, but it's never used.
Yeah, so Visual Studio is always thinking about ways to help you do stuff.
Right, so
So
that's
the-
basically saying that those variables weren't necessary because they were declared, but you never actually used them in your code.
Now this if statement seems kind of scary and complicated, but I bet you that we can kind of break it down. I think it's okay if I add some white space to make it simpler. And by make it simpler, it's more just for my own emotional well-being. So that if statement that I copied from the page here was a little bit intimidating. So I broke it up onto multiple lines just so I could get a sense of what was going on. So this one says if I add these together and they're greater than 10, and that's either true or false. And then this one said, I assume if A equals B. What's going on here though?
Right, so that's the AND operator, which basically just combines the two different conditions. So the AND operator means both sides of the statements on either side of it need to be true in order for this if statement block to execute.
Okay, so if true and true. If true and true, so true plus true equals true.
Right.
That makes sense. And if I put that back all on one line, well, again, it might be a little intimidating. You'll see a lot of these and get used to them. So here we can go and run that. And it'll say, yes, the number is not greater than 10, and the first number, oh, interesting, or, well, here I've got some different code. I want to say not and, either thing can be true, and then that would be the case.
So here just one side needs to be true.
Okay, so if either one of those is true, so in this case here, either the answer is greater than 10, which it is, or the first number is equal to the second, which it is not. So that makes sense. That is true, and that is false. All right, so let's move on.
Ooh, it gets really long over there.
That's intimidating. I am feeling more and more uncomfortable about all this other stuff going on here.
Yeah, let's take a minute to break down everything, well, the envelope of all C# programs in the next video. So we just covered branches.
Hey, we're learning about C# 101, and we've been talking about branches. But, you know, when we learn about C# and we learn programming languages, there's always a hello world. And Kendra, I always feel like teachers skip these scary parts. And I've had it. We were in the middle of learning about branches, and I still don't understand what's going about here and you told me to ignore it,
Right.
I can ignore it no more.
Okay, well, let's go ahead and trim down this program to just the console.writeLine. We remember what that looks like, right?
All right, so I'm going to go ahead and remove the stuff that we were working on.
Right.
And I'm going to go back to hello world is what I'm hearing you say. So
Right, so-
console.writeLine, hello world.
Great.
And I know that part because I can do that in the browser, in my in-browser tutorial. But I don't know about all this other stuff.
Right, so this is basically the simplest possible C# program. Okay, so first off, let's start at the top, talk about the using system.
Okay.
So using statements in C# are just importing other libraries that you may want to be using. So I actually believe console uses the system library, and that's why it lights up in that little blue font.
That's a really good point. Notice that when I hover over it, and this is what's great about using a tool like Visual Studio, is it's telling me it's system.console. So in fact, I can say system.console. Ready? I can get rid of that, and it'll still work. But I don't want to type system.console.writeLine all the time. That's no fun.
And you'll likely be using system a lot in a lot of other places throughout your
Exactly.
code. So we like to keep that as a using statement. That's why it's there by default.
And you see how they grayed it out. This is Visual Studio saying you don't really need that, but I'm going to say I do need it, and that lights up again. So
Yeah.
this makes my code simpler, doesn't it?
Yeah.
Okay, so that's cool. So I understand using brings in other libraries that I can go and use and makes the scope of them simpler. But then what's a namespace?
So namespaces are basically just used to group and organize code. So if you have multiple different classes, which we'll talk about next, so you have a program class right there.
Right.
If you have multiple different classes and they're all very related, you may want to group them in a same namespace just to keep everything organized.
I see. Okay, so console is a class. We can see it says class system.console. And namespace is the envelope or the package that it comes within.
Right.
I bet you there's a bunch of other stuff. If I say system dot, these are all the other things that are hanging off of system.
Yeah, that are all in the system namespace.
Right. Remember we were talking about ints and strings. They're all part of system as well, right?
Right.
Okay, so then system is system.this and system.that. I'm making my own package, my own place, my own namespace called console app 6, which is not a really good namespace.
Right. So there's namespaces that are already built that come with the tools like System that's provided by Microsoft. But then you can create your own. So that console app 6 is your namespace.
Cool, and we'll talk about how to make your own in the future, both classes and namespaces, and then use ones from the community as well. Okay, so using, I understand, namespace, and it's kind of cool that namespace kind of has a little bracket here. It seems like there's a, oh, look at that. Okay, so that's the thing that holds these things, right?
Yeah.
All right, and then class, look at that, it's holding these. What's static void main string blah, 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 args?
Blah, 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 blah. Yeah. Well, that is your first method. So every single program in C# needs a main method, which we see as the entry point. So it's basically telling your computer, this is where the program starts.
Okay, this is the go, like this is where you start, but it probably can't be named go. It actually has to be named main, because it's the entry, it's the main place to start.
Yes.
Okay, so that makes sense. And it's static. When I think of the word static in English, it's like unmoving, unchanging.
That's exactly what it is. So the main method also needs to be static, which means it's not going to change dynamically as the program's executing.
Okay, and then we've got this thing here that says void. Void implies like nothingness or emptiness, or like
Right.
not doing something.
Yeah, so this is all methods in C#. You need to specify if the method returns something or not. So methods could return like an integer, like if you're doing a bunch of compilation, all to result in an integer, or all to result in like a string.
Okay,
Boom.
but ours results in nothing because
Yes.
it does consoles and then it's done.
Yeah.
Okay.
So that's why it's void.
So it's unchanging, it doesn't really return anything, its name is main. Then the last
main
thing that
method.
we don't understand is string, brackety things, and then args.
Right, so that's a string array of arguments. So any kind of program may have arguments input into it as it compiles. So when I started off, I'm saying, take these arguments and do something with it. So C# starts out with the option of having a string array of arguments. So you can actually call that args variable and figure out if anything is being input into the program.
Okay, cool. So if I name my program Console App 6, I could say, hey, Console App 6 space Kendra, and then I could make this say, hello, Kendra. And
Yeah.
that would be an argument that was passed in. And it sounds like the array means some number of unlimited arguments.
Yeah, you can have, an array is just like a list. You can have multiple arguments passed in.
Yeah, and we'll talk about lists and collections a little bit later.
We will.
Okay, cool. So now I understand that these things mean something and they matter. And even though I don't want to think about them, and I'll just spend my time here for branches and loops, that's really the structure of a Hello World application. Thank you for explaining that to me.
Of course.
All right, we're going to jump back into branches and loops now that I understand the structure of Hello World.
Hi, so we just talked about if statements and branches in C#. Next, we're going to talk about loops. We also got a chance to go over the using namespace classes, the methods, everything you need at the beginning of your program to write a C# application.
Right, we were in the middle of doing if statements, and then I got freaked out by all of this. So we explained that. So Kendra had the Hello World explained. So now I can explore that, and you could also spend some time with that at home. But we're moving forward to loops, using loops to repeat statements.
Right, so the most basic loop in C# is while. So while is whenever this condition is true, just keep on repeating it. So once it executes the code block once, it'll go back up to the top of that while loop, verify if the condition is still true, and then execute again. And it can just do that forever if it always finds the condition to be true. So
I'm going
use
to take that code.
cautiously.
I'm going to take that code and I'm going to drop it into my main here. And it's kind of hard to figure out how you should think about a statement like this. Like, should I read it in English or in my native language? Sometimes I read it like, while it is the case that this is
Counter
true.
is less than 10.
While counter is less than 10, do some stuff.
Right.
And sometimes you'll see people say, while true, which is kind of weird. But true is always true forever. So that
Yeah.
means while true is true, which is forever. So while true means forever, which is kind of not really intuitive.
So that's what we would have an infinite loop in that case.
Actually, let's try this one, and then we can try an infinite loop and see what while false does as well.
Oh, good point.
So let's do that. So I'm going to hit Control F5.
So here, okay.
So that's,
So printed this thing out 10 times.
so we started with counter, which is an integer. We learned about those. While it is the case that counter is less than 10, do some stuff.
So it has a write line.
Right,
And
and
in
our
this
write
write
line
line,
has-
yeah, we print out the counter variable.
Okay, and then look at that. Counter plus plus. That's interesting. We could have said counter equals counter plus 1, but we just said counter plus plus, which makes it faster. And we could also say counter minus minus if we were going down.
Right, so that's just incrementing counter by 1. The
Exactly.
plus plus operator.
Right. Now, if we said while true, I wonder if this will crash my computer.
Oh, so it just keeps going and going forever until your computer runs out of memory or your battery dies.
Or if you remember, we did our talk on integers. So
Right.
this will go until it runs out of room.
Oh, that's true. Yeah, your integer could be the thing that actually crashes it.
Yeah. So in this case, we could go up to what would we say? 2 billion.
2 billion, yeah, or
Right?
causes an
And
exception.
if I change that to a short, which we saw was a really small thing, while true means forever, but shorts aren't forever things, right? Shorts
Right.
only go into the 30,000s. So when it hits 30,000, it'll probably just freak out.
Oh, yeah, okay.
Isn't that interesting? Oh,
I like this
oh,
experiment.
ooh.
Oh, that's right, because we were just talking about how once integers went over, it would just take over sort of like an old odometer.
So that flipped over. Isn't that interesting? So we're actually going, now what do I do though? How do I stop it?
I think you just have to exit out of the program.
Yeah, so I can do two things. I can either close the program, just like this, and hit close, or I can hit Control C, which breaks out of your program. So if you ever get in trouble, you can go and Control C. And another great way to get out of trouble is undo, right? So I messed my code up. I'm going to go ahead and undo back to where we were before. So that was interesting. I learned a few things right there, huh?
Right, so we talked about the incrementer. What's next?
Well, we said while it is the case, but we can also flip it, right? We can flip it so that we do something no matter what. And then we have the conditional or the check, because inside the while is an if statement, isn't it? It's kind of it's a conditional. So we're saying do this
Right.
while that, which is flipping it on its head a little bit, actually.
Right.
Let me
So
go ahead and
the
remove that.
condition isn't checked till the very end. So you will definitely execute the code at least once, and then the condition is checked.
Right. So if I do this one, the result is the same, but if I did something like 10,
Ooh, yeah.
right? So counter is going to start at 10. It'll always at least do the first,
And then it hit the condition and it stopped the
and
loop.
then it stopped because at that point counter was 11. So do and while are kind of friends. They're kind of, there's a while and there's a do while. So that's kind of interesting. And they produce the same output in this particular example, but that's something for you to watch for.
Cool. And now my personal favorite, the for loop.
This is, for some people, and I would say for myself as well, the hardest one to get your head around. But once you've got it, you're going to use it all day, every day.
Yes, it is definitely my preferred loop. Even our docs say it's the most commonly used loop in C#. So
Bring that in.
yeah.
Now, what do I read? Like we said, while it is the case that this is true, but there's a lot going on here. There's 3
Yeah.
different pieces.
So I think a good way to approach it is, you know how you had the counter declared as a variable outside of the loop when it was while?
I did.
For for loops, you declare that variable inside the for statement. So that's where we're saying int index equals 0. So that's sort of our counter variable.
Okay.
And so we're just saying to repeat this while index is less than 10. The next statement there is basically the condition.
Okay.
And you might also recall we were incrementing counter within the while block.
Right.
With for loops, we can actually increment it as part of the loop statement. So it's sort of easy to see all of that in one place, so I know exactly how many times I will repeat this loop under what conditions and what my counter variable is.
That's a great point. So you've got the initializer, your startup, your setup, your initial state. You've got the condition, and then you've got the iterator. That happens every single time, right?
Right.
And this can be confusing to remember, but if you're using Visual Studio, you can just type for, and if you hit tab, it'll go and snip it. It'll expand out and tell you kind of how to do that, which is kind
Wow,
of cool.
I need to use that more. Yeah,
that great?
definitely.
Yeah. When you're typing in Visual Studio, if you see a little box that is like, see, it says code snippet, tab twice to insert. And there's other iterators like for each, and then also ifs that we did before. Look at that. So if you get
very
used to
nice.
those, you can move a little bit faster and you can type a little bit less, which is fun.
Oh yeah.
All right? Cool. So I think that's probably a good place to stop, and then we'll come back and we'll then combine branches and loops together.
Sounds good. So we just went over loops in C#. Now we're going to combine branches and loop statements in a bit of a challenge.
Ooh, challenge time. All right, so let's do this. I'm going to clear out my main, my hello world, because I know that the challenge will go here. So let's see if we can combine ifs and looping constructs and solve this. So what are they asking us to do?
Right, so at the end of this doc, we're getting some instructions. So see if we can write C# code and find the sum of all integers 1 through 20 that are divisible by 3. And I guess we'll just print those out.
Okay.
Okay.
So all integers from 1 to 20. So for 1 to 20.
Right, so we'll probably be checking all integers 1 through 20. So let's create a for loop.
So I'm going to do that. See, I just do that again. I type for, and I can go tab, which is kind of
Magic.
cool. Or I could type it myself. I could say for, open the parentheses up, and we said we would start with something, right?
Yeah, and we should probably start at 1
Okay.
because instead of 0, this says check 1 through 20, and then semicolon to start the next section.
Okay.
So
and this
while
is the if statement.
yeah, so while while I is less than 20 is probably
Well,
what we want.
is less than 20, but it would be 1 through 20, so it would be either less than or something we haven't seen before, which is less than or equal to 20,
Good point.
or we could say less than 21. Kind of depends on how you think.
Right, so it would stop when I was 21, which would have been right after it had run when I was 20.
Right,
and
and this
printed
is
that out.
this is a personal taste thing. I kind of like that one. Let's see if that works, and if
Yeah,
it doesn't, we can try it another way. Okay, and then I needs to go up.
Right, so I++.
I++. All right. Now, when you're typing, your code isn't ready yet. It's not complete. So Visual Studio might be giving you little squigglies. And that can make you nervous as a new programmer, and that's okay. They're telling you that something's expected, and that's fine. We're not quite there yet, right? We haven't made the full statement. So don't worry until you think it's done, and then it doesn't work.
Right.
All right. So I added some braces right there, and I'll do that again just to show you.
This will probably be multiple lines.
And when I made the opening brace, Visual Studio gave me the other brace. And you might find yourself in a situation like I just did, where I actually deleted a brace. Make sure you kind of count them. You can see I'm in fact missing 2 right there, and the squiggles will go away. All right, so 4 divisible by 3. So we're not counting all numbers
No.
over there. We're doing just the one divisible by 3.
Yeah. So let's check if I
If,
is divisible by 3.
so I can go divided by 3, but that's not really what I want, right? I want to know if it can be divided.
You want to make sure it's like evenly divided by 3.
Right. Now remember, integers are weird because when you divide by odd numbers, you can get remainders.
Right.
So what do I want to do? I want to say,
Use the modulus operator.
okay. Now can be a little confusing. So you're saying if this is divided by 3, but it has to be a Boolean. See how it actually says that? Look, I can't make an integer a Boolean. We're trying to divide by 3.
Right.
The remainder is a Boolean. So how do we do that, right?
Well, we want to make sure that the remainder is 0 because it evenly divided.
Right.
So let's put equals 0.
Right, I misspoke. The remainder isn't a Boolean. The remainder would be 0 if it was a smooth division.
Right. If it went well.
So if it went well, equals 0. Okay, so if it's the case that 3 can be evenly divided, cool.
Yeah. So it looks like we went to, did it say report the sum?
Write code to find the sum.
Sum of all integers. Okay, so let's create another variable that will keep a tally of all of the numbers adding up.
Ooh,
so
and
we'll
this brings up a good point, because I could make the sum right here.
Oh, right.
Yeah, let's do this. So if I go sum, and then I say, okay, sum equals sum plus number.
I.
Oops, not plus I keep saying number. Let's say I.
Yeah.
This is kind of interesting, because here it says, well, I don't know what sum is, and I'm putting this integer inside this if, inside this for, inside of main. We're thinking about what's called scoping.
Yeah. So we actually want this sum to, every time we iterate through the loop, we want it to add I if it qualifies and because it's divisible by 3. So we want to declare sum outside of the for loop.
Right, otherwise we'll get a new sum each time. That sum
Right.
will always be the wrong number. So we're going
Yeah.
to take that int sum and would we put it here? Is that far enough out?
Because we want it outside of the for loop.
Okay, so we'll put it out here.
Yeah. So this way, when we repeat the for loop, that sum variable will just be continually adding up and not be reset
Right.
with each loop.
And then now it's saying it's been unassigned. We need sum to start at something. Do we start at 1 or start at 0 or start at 2?
Yeah.
We'll start at 0. So we're going to go and be specific. When we make a new sum, our sum will start at 0. And then when we see something divisible by 3, we'll go and we'll do the adding.
Yeah.
Sound good? And then where should we go and do our console.writeLine? Probably at the end of it all.
Sounds good.
Console.writeLine. You see how that's called IntelliSense? It's giving us a hint, and I don't have to type. And then let's put a string, and let's go and say the sum is sum. And then see, I always end my statements with a semicolon. Cool. Now, this is where you look at it and you compile it in your brain.
And I'm like,
I
ooh,
think
yes.
it's going to work. I don't
My
know.
brain compiler.
Yeah, or we can just run it and see if it works.
I like doing that too.
All right, let's take a look. Sum is 63. Is that the right answer? Now we got to figure it out.
Yeah.
Oh, here it says, look, you should get 63 for an answer. I mean, you can check one possible answer on GitHub. And the really good thing about this is that your answer might be different than our answer, and that's okay as long as it worked. And in future videos, we'll talk a little bit about testing and things like that, asserting your assumptions. But I think we got that one right. We got that challenge right. We successfully combined branches and loops together in a C# app that actually does some stuff.
Cool.
All right, so we're going to take a break here, and we'll come back and we'll talk about like arrays and collections and putting all of this together into an even more interesting application.
We just spoke about combining branches and loops, and now we're going to talk about arrays, lists, and collections in C#.
So I'm going to switch back to where we were before. We were just working on our branches and loops. So click on arrays and lists. And we're going to go through this basic list example. Now they're telling me to make a new application, but because I know now what Hello World looks like, I can just delete that one and keep reusing my same application.
Definitely.
Okay, and I'm going to take just the code inside of the main here and put that over here, and let's take a look at what's going on.
Yeah, it should give you, there's a little error.
Yeah, this is interesting. So we're saying var, which I've never seen before, and then new list. So there's actually two things that are going on here. Why don't we fix that one, and then you can explain this one here.
Sure. Yeah, errors always get the priority.
Oh, yeah.
So actually, if you see a little light bulb popping up in the margin, there it is. Why don't we go ahead and expand that? So this is recognizing that this type, right now it's a collection of a generic type, isn't imported. So remember, we were talking about using statements being namespaces that you could use the types of in your program.
Right.
This is just warning you, hey, you need a system.collections.generic import statement at the top of your file.
Okay, so if I didn't have using system, it would complain that console wasn't there because it's system.console.
Yeah, you get a similar error.
And list is a system.collections.generic.list. So I can just go like that.
Yeah.
And look, it put that in there for me. It typed that for me. And this now doesn't squiggle,
yeah.
which is pretty sweet. Okay, cool.
So those little light bulbs are often really great hints for if anything's going wrong, should be able to help out.
Right, there's lots of light bulbs. Another light bulb that's popping up here is we're saying for each, which we haven't learned about yet. But there's a light bulb there that's saying you should be explicit. You should be very specific instead of saying var or var. What is var doing here?
So var, I am a pretty big fan of var. Var is what you put when you do not know what this variable is going to be.
Nor do you care.
Yeah, nor do you care. So you can just start typing, and so it's great. So if I did var, do you want to create a var, var int var I equals 0?
So we've been doing this. We've been making ints all this time, right?
Yeah.
So if I go var I equals 0, and I go I dot, I'm getting inty things.
Yeah. So if you hover over I as well, I think it'll actually indicate that this is an integer.
It is.
So this is just our compiler automatically inferring that because you have a 0 on the other side, they're just saying, I'm going to guess this is going to be an integer.
Yeah, but if I go and say Scott, and I hover over it, it immediately knew that it was a string. And if I say I dot, look, trim end, those are our stringy things.
Yeah.
So var is cool if it's like, I don't really know, I don't really mind. So I could say, and this is where it gets really useful, list of string called names. But now I've said list string twice, and it's kind of giving me a headache, and it's just faster to type var.
Yeah.
And you might
shorter, too.
find that people might not like that because it's a style thing, isn't it?
It is definitely a code style thing. So this is also something you can configure in Visual Studio to prefer var when the explicit type, that being the list of string, is apparent, meaning it's just obvious what this type is. We don't need further explanation.
Yep.
And use explicit type in all of their cases. And that's what it's set to now. So if we look at the var, the squiggle under the var in the for each loop, it's saying that, hey, it isn't super obvious what this is.
That is a good point.
It
It
should
is
be-
obvious here. It's
Right.
kind of not obvious there.
Right. Just in the for loop. There we go. Just in the for each loop, we now have a string.
Okay. So here we're saying, with our list of names,
Yeah, definitely personalize this list.
personalized,
Much better
very,
now.
Very important. So we're saying for each of those names in names. And this is very common, this singular and plural. That's not required. I could call names foo, and I could say for each name in foo, but it's kind of nice to say for each name in names,
Yeah.
for each product in products.
So names is my list, and when I'm going through my for each loop, I'm choosing one item in that list and storing it in that name variable. So we had iterators and indexes in our last examples, or like
Right.
counters, and those would naturally increment every time the loop executed. With for each loops, it'll just grab the next item in that list. So it's a good way of transforming anything in a list.
That's a good question, actually, that I'm having in my mind here. Let me ask you this. Would it be okay if I did this? Could I do this?
Names, length. Yeah, I think I see where you're going.
Right?
So,
And then I could take this console.writeLine, and could I say name I?
we want to use
But
names.
I see I can't. I got to go names I, right?
Right. So
That got a lot more complicated. I get it, but it's not as nice to read as that, is it?
right. So you're using the I index to tell the for loop, or to tell names which item in the list you're grabbing. So
Right.
it could be the first or second, third, whatever.
So we're digging out the 0th, the first, and the second, but that is a little harder
It's
to
more,
read.
Definitely.
I just want to go through the list. I mean, I can do that, but isn't it nicer to do it the other way? But the nice part is that we can do it either way.
Yeah, definitely.
Yeah, definitely. So let's switch back over here. We can go, and actually, we should see if it works. Let's do it both ways, because who knows?
Oh, yeah.
It did work. So this is really important to point out, because it not only worked,
All
but it in
caps.
fact worked both ways.
Yes.
So it is showing you that they're kind of the same, but you want to use the one that makes you happy and the one that means what you want it to mean. So that's a good reminder.
Definitely. Another sort of just style thing. One of the things that's really fun about programming languages, it is very much like writing style, just how certain authors have different writing styles when they use English or when they're writing different books. C# is very dynamic and kind of personalized.
Yep, that is a great point. So let's remove all of that, and we'll just start with our list of names. And one of the things that we can do is we can say names.add. We can add our friends to that list of names. I'm going to say names dot. These are all the things that a name can do. We can add and it can remove. Okay, and then I can say names.remove, and let's remove me, because I've left. And then we can go and do that for each again, for each name in names. And then we'll say console.writeLine. And let's just go and print out, we'll just print out the names again. Is that cool?
Yeah.
And then again, I can decide if I want to make that a string or just a var. Totally up to me. I'll leave it as a var and see if it works.
Okay.
Yep.
Cool. So you've been able to actually remove and add items to the list of string. What is list of string? What is that syntax?
Yeah, isn't that interesting? That is called generics. So if you're out there searching the internet and you're finding out what's going on, you read that as a list of string. And list, they say, can be of any type. And they usually say it can be of any type T. I can have a list of ints, or a list of string, or a list of pants. So this is actually a programming joke that you taught me. You can have a cup of tea.
Because it's a cup of type T. Okay, yeah.
That's your
a
first
cup of
programming joke in C#. If you liked that, then you should be a programmer. There's a lot of nerd humor available in the programming industry. So definitely just casually drink your cup of tea and see if anyone else notices. And I think you'll be a winner. Yeah, and then just at the end here to point out the indexing part that we did, I can say names, and I can put it into a bracket there. We talked a little bit about brackets and arrays when we talked about args.
Right.
When you explain that, I could say, give me the 0th or the first name. So let's do this. Console.writeLine. Notice how I spelled those wrong, and it's going to squiggle on me, isn't it? It's got to be spelled right, and it's got to be uppercase and lowercase correct. So what is names at 1? It's not names of T, it's list of something, and it's names at 1. I would expect that would say Scott.
Yes. So that's another thing to call out.
It does not. Why not? Trick question. I removed myself.
Oh, you did remove yourself.
Yeah.
Ooh.
Yeah. So I removed myself, and you are the first one now. So imagine we had name, which is just words, Scott, Kendra, Maria, Bill. We removed me. That shifted you up to the number 1 spot.
Yeah.
So now you're
like
number
it.
1 in the names list.
So speaking of the number 1 spot, what's in the 0th spot?
That is a weird spot. I'm actually going to change that, and we'll just say that that's weird. We'll have a spot that's called weird. It's the 0th spot, isn't it? It is this everything in an array is zero-based. Zero is the first place. I don't know why. It's always been that way.
It's kind of a big characteristic of programming languages, whether or not they're zero indexed or start at 1. So C# is 0.
Yep, and there are other languages that are 1 indexed, but you just remember that that's the first spot is the 0th, the second spot is the first, and you go from there and you'll be fine. And those are some of the errors that you'll find as you go and play with lists, is you might be off by 1. And that's okay, because you'll be able to write it and try again. All right. So that is a little bit of an understanding of lists and collections. Let's take a break and we'll come back and talk about how to search them and sort them.
So we just covered lists of strings in C#. Now we're going to sort, search, and index these lists.
Let me switch back over here. I've got my tutorial on the left and Visual Studio on the right. And when we last left our heroes, we were saying names at 0. And we noted when we ran that weird, who is our weird friend, that weird friend is the 0th item. So it's they call it the index of that.
Right.
So that's kind of weird.
So let's dive in a little bit more into indexes. It looks like our docs are saying there's another way to access an index.
Yeah. So we could go and say var and grab an index and say names dot index of. So I can actually ask the array or the list, the collection, hey, where is Kendra? What is the index of Kendra? So it's actually going to search for you in that list. And then I'll go and console.writeLine index. Maybe I could even go like this and I could say found, well, I guess I'll just say Kendra because I've hard-coded you here, at index. Okay. Oops. Always a little syntax here and there. There we go. Let's try that. Sound like a plan?
Yeah.
And we'll get rid of our weird friend there. Control F5 or hit the play button. Found Kendra at 1. So 0, 1, 2, 3. Oops, there's Bill. And just to confirm, found Bill. I expect to.
Right.
No.
0, 1.
0, 1, 2, 3.
Oh.
There we go.
Okay, yeah.
Forgot about Maria there. Yeah, that's my bad. Now, what if we search for someone that doesn't exist?
Ooh, I don't know.
Let's search for Scott, who we have previously removed, right?
Yeah.
So index of Scott.
-1.
Now it says found because I wrote the word found, but it didn't actually find it, right? So that's interesting. Now we can combine that, as we see in the sample here, with an if statement. If index is not found, else. So why don't we try that? That's interesting. I'm going to copy that code in here, and I'll make it a little bit bigger. Oops, let's put it there. So if index is -1, when an item is not found, index returns index. Else, the name, and this is interesting, look.
Is that index?
Names at index. We're going to take the index that we just grabbed. So this is the number of where Scott is, or not, and then look it up, and then print that out. So what do we think is going to happen? Is Scott in there or not? When an item is not found, index of returns -1. But if we go in here and we put in Kendra, we do it again. Ah, so let's look at that. The name, names at. That's how I think of that. So we saw that cup of tea with the less thans and greater thans, and then when you're doing a list or an array, it's at, which is the square brackets. Make sense?
Definitely. So now we know how to find the index of where something is in an array. So that's a type of searching.
Right. Let's sort, because we've been right now just putting these in whatever order, right? We'll put me back in, so I'm not going to remove me right now.
Good. I wanted you to be included.
I appreciate that. And I'm going to go and have, right now, our original list. We'll change weird to new friend. We've got new friend, Scott, Kendra, and then we are going to manually or programmatically add Maria and Bill.
Sounds good.
Then we're going to spin through our list just to confirm what that looks like.
New friend, Scott, Kendra, Maria, Bill. Yeah.
Okay, cool. Looks good. Now they're telling us sort the array. Now this is an interesting thing because I would have thought that I would have to say names equals names.sort,
Yeah.
right? Because I did replaces before and I did different things.
Yeah.
But in fact, sort does it in place, right? It sorts it on the spot. It doesn't make a copy of it, which might not be intuitive if you haven't seen that before. So let's see what we get when we sort our people.
Oh, cool. And it just knew to sort it alphabetically? How did we know that?
Right, that's a great question. So if we hover over sort, we can ask that question. It says,
the elements.
using the default comparer.
The default comparer, of course.
Of course, the
What?
comparer. Well, so it turns out that this is a list of strings, but it could be a list of T. It could be a list of anything. So when you compare strings, is this string less than this string? You actually have to do that. You can say, is the word Bill less than the word Kendra?
Right.
And because Bill comes before Kendra in the alphabet, Bill is less than. It's less than in
Gotcha.
air quotes. So that's the comparer, and that's how they sort.
Even without air quotes, because each character in a string does have a numerical value.
That's true.
So like A is a very low number. So even if the string was converted to a number, sorting them would still have, smallest at the top, biggest
That's
at
a
the
really
bottom.
great point, because because remember we talked about strings. Strings is a friendship necklace.
Right.
It's actually a friendship bracelet or necklace of characters, or what they call chars, and those chars have numbers.
Yeah.
So yeah, you could sort the characters within a string, and that would be something as well. That's a really great point. I didn't think about that. So when we go and do something like this, we can look at a larger example. Here's a bigger example that you could mess with. And actually, let's do this. Let's just copy that whole example.
Ooh, yeah.
And I'm just going to go and Control A for all and Control V for paste. And let's just kind of zoom out a little bit. Got a whole big example here. Let's run that. So we can see in the tutorial all the different things that they've done, where we've removed names, added names, sorted names, seen them move around. This is a great little example of all the different things you can do with lists of stuff. But in this case, we've only talked about strings. So let's take a break and we'll come back and we'll add other types, other stuff of T
Sounds
to
good.
our lists. All right, we've been putting things in lists. We had strings in lists, but we can also make lists of anything. Like we talked about a list of T, where T is any type. Let's put some other stuff into lists. So I'm going to switch over back to my tutorial. I've got Visual Studio on the right, I've got my tutorial on the left, and let's put lists of integers together. And this is interesting too, because we're actually going to put stuff in the list right off the bat, just like we did when we put in lists of strings. So let's delete a bunch of code, shall we?
Right.
Put it back the way it was. We're going to start from scratch. So I'm going to go and delete all this down to there. Hello world.
All right, back where we started.
Back where we started. You can make a new project if you want to. And then I'm just going to copy paste there, and I have Fibonacci. Fibonacci. What is Fibonacci?
Fibonacci sounds pretty fancy.
Mm-hmm.
So Fibonacci is basically just an algorithm. So if the Fibonacci sequence is where the first two values of the sequence are added together, and that creates the next number. So it could basically go on infinitely. So if you start with 1, the next number would be 2, the next number would be 3, the next one would be 5, next 8, and so on and so forth. Oh, and you can even look up the Wikipedia page. There's actually a ton of interesting stuff to look into, like the Fibonacci spiral,
The golden ratio.
the golden ratio. So I'm a huge geek about the numbers. But if you look into it, there's actually a lot of things like in nature that mimic the Fibonacci sequence, which is just super cool. So anyway, let's show how to show it in code.
Yeah, so there's lots of ways to express this. You might, if you've taken a programming course before, they might ask you to do a Fibonacci sequence. There's lots of ways. So this isn't the way, it's just a way, and it's fun for us to do it because we're learning. We made a list of ints. We put 2 ints in them, the first 2 numbers of the Fibonacci sequence.
Yeah.
Right? And then I can take this code here and I'll paste that in. And let's just take a look at what's going on here. Here, we are going to look at the previous and the other previous. And this is interesting because we're actually taking the length of the list minus 1. Now, is that the last number or the one before the last number? Remember that lists are zero-based, so that can be a little confusing to new people.
Right, so it should be the last number.
Right, which isn't intuitive. If I go and say, give me the list at the end, I might think I would get the end, but in fact, I'm going to go 1 off the end.
Right. So that's because you have, in your Fibonacci numbers list, you only have 2 elements. And that dot count will return 2. But the index is 1 off because the index, again, starts at 0.
Right.
So the indexes of your 2 elements are only 0 and 1. So anytime you want to grab the very last element in the array, you need to look at the dot count, which is, again, the total number of elements you have minus 1.
Right,
And that'll
so
give you the last index.
It says the index was out of range. It must be less than the size. So count is the size. So we need the number that is less than the size, right?
Right.
So what you said was 1. And then we want to get the last 2. So we're going to kind of jumping backwards, go get that one as well. And then we take the last 2 numbers, in this case 1 and 1. We add them together, like we've added before. We've added integers before. And then this is the cool part. Then we add it to the list.
Yeah. So it's continuing the Fibonacci sequence.
Right. So in this case, we then spin through it with a for loop, for each loop rather. And you'll note that we didn't put our curly braces around it because we're just doing 1 line. So that's fine for now. And then let's see, we should see 1, 1, 2.
Yeah.
So that worked.
Looks good.
Okay, so challenge time.
Challenge time. The next part of the doc has a challenge, and that's to basically print the Fibonacci, generate the Fibonacci sequence of the first 20 numbers in this sequence.
Okay.
And we have a hint. So we know the number we're shooting for is 6765.
Okay, so that's our final number, the 20th number, then we did it right. Now again, some of you may be advanced, or you may be sitting with someone who's advanced, and they may be saying, well, this is not very efficient, fancy. Well, it's not very efficient or fancy, but it's fun, and it's a great way to exercise our ability to play with lists in C#.
Definitely.
Yeah. All right, so the first 20 numbers in sequence.
Yeah.
Well,
so-
I know that's where we started, right? And that one's
yeah.
allowed.
Yeah, we should keep that.
Okay.
And then we just need to get the next 18 numbers, I guess.
Well, we could do a for loop. We could do a while loop.
Well, sounds good.
Okay, so while it is the case, how do we know if we have 20 of these?
Let's go ahead and use the Fibonacci numbers.count so we get the size of it.
Okay, so this is a list that's going to keep getting bigger.
Yeah,
And when it gets over 20, if it gets to 21, then we're done.
right.
Okay,
so
cool.
the 20th time it executes will be the last.
Okay, cool.
Cool.
And then let's take these things here and let's put them inside because we need to do that 20 times, right?
Yeah, sounds good.
this is
so
interesting.
we're going to be adding a new element to this list with every single time we iterate through.
So this is interesting. We're doing a loop on a changing target.
Yeah,
So this thing's going to get bigger and bigger and bigger while we're standing on top of it. Yeah. So first time we run it, it's got 2 items in it. We grab those 2 items relative to the end.
right.
Yeah. Make it bigger. Go through again. It's got
Now at
3
3.
now.
Yeah.
Grab the last 2, add them, and now it's 4. So this could get big, and this could, remember that time when I did a while loop and it filled up
Went
a
on
short?
forever.
I might be afraid that I'm going to go too far.
Yeah.
But,
But we've got our count limit on it. Should be less than 20.
all right, let's see if we can do it. Control F5.
Hey, 6765.
Whoa, we got it on the first try.
Nice.
Winning it live.
That's why they
Interesting.
make us do these videos.
This is true. And actually, just to point out, if we said less than or equals to, which might feel intuitive
Right.
to you, right? That went 1 additional.
Yeah.
Because the size of the thing was 20, we kept going, added the 21st, and then we stopped. So these kind of errors, wouldn't you say that's the most common error? I mean, my life is just off by
Yes.
1 errors.
Off by 1 is so common. So if you run into that, you are not
Don't feel
alone.
Don't feel bad.
We do it today, every day.
All day, every day. So just something to think about. And there's lots of ways to solve that. Like if you feel that it's less than 20 or less than or equal to 19.
See?
Whatever reads best to you.
Yeah, also a totally valid way to write
Yeah,
it.
I think you and I agree that for us, that feels like a good way to write
I
this.
like nice round numbers.
Yep.
So we just learned a little bit about the Fibonacci sequence. Now we're going to take a look at the debugger. So we just went over the Fibonacci sequence. Now that was pretty complicated. Are there any tools we could use to make that a bit easier?
I definitely have an idea of how we can make that better. Let's try this. Let's go and do that. Now notice I keep pressing Control F5. That's what I'm doing. Been doing all these videos. I've been going and saying start without debugging. But I don't necessarily want to do that. I'm going to try something different if that's okay with you.
Oh yeah.
Why don't we do this? We have never done this before. I'm going to click over here in the
So
left.
what did you just do? What's this red dot?
See this? This is called a breakpoint. There's lots of ways to do this. I can click in the margin.
It almost looks like a stop symbol.
It does look like a stop symbol. I could go and say insert breakpoint. I can go and press F9 if I like my hotkeys. But lots of people just like to put their stop symbols over here. And then I'm going to hit the play button. Hit play. This is F5 instead of Control F5 on your keyboard. And everything's changed and I'm freaking out.
What are
What's
all
happening?
these windows?
So all these things popped out to make my life easier, and you might be initially kind of shocked, but you can move those splitters around and see what's going on. It'll show you a bunch of stuff, kind of like a car dashboard. Maybe more than you need, but let's just worry about the left side, where our code is, and this. Look at that.
So this is all feedback on sort of the execution process. So I'm actually like paused in the middle of
We
executing
are
all of
paused,
this code.
aren't we? You're absolutely right. We were in the middle of watching our show. We paused it in the middle, maybe to fast forward a commercial. Where are we in the process here? Are we on the first time through or the 20th time through? How can we tell?
I believe it's the first time through. So we can
Right.
actually inspect our variables. So the number of Fibonacci, like how many items are in that array, it still says 2.
Yep,
We can
so-
see that in our autos window down at the bottom.
Yep, it is the first time.
So it's keeping track of all of the variables that we have in our current scope.
Right, and we have not yet added that first number, which would be in this case what? 1 plus 1 is 2.
Right.
So we can go and hit our step over button. I'm going to hit F10. If you don't see yours, you can make sure if you right click up in the toolbar that you have the debug toolbar button
those
there.
little
See that?
arrows.
Show next statement, step over. What we're looking for is to step over. See, it's a dot. That's that dot right there. We're going to step over that dot. And look, see, it actually turns red to tell you what changed. It added a new thing. Now here's
So
here's
now
a fun
there's
thing.
3 elements in that array.
So I'm going to put my finger on F10, or you could go and just click right here and watch.
Whoa. So you can actually see it circling through your while loop.
This is a great way to remind yourself, if you're a new programmer, how this stuff works. That is a even though I'm clicking fast, it's a slow motion version of what's happening. So let's stop right there. We're at 14. See? And I can open that up and look, there's my 0th and my 1st and all the way down to my 13th. Now, here's a trick. You showed me this trick. I can go and put another breakpoint here and turn that one off, and I can continue, and it'll go there. So I can basically move the stop sign.
Right. So instead of clicking through like, 18 more times
Or a million
however
or
many you need
whatever,
to
yeah.
get through that array,
Yeah.
you can just hit
Or,
the next breakpoint.
This is great. Run to cursor.
Ooh, I love this
Yeah.
one.
So I'm not going to put a breakpoint. I'm just going to say run to here. And now I've stopped right there.
Oh wow, and your Fibonacci numbers count is already at 20 because we're done with the while loop, and now we're just printing it out in that for each that goes through the console write line.
Exactly. And remember, there's 20 items there. You have to get used to that 0 base thing. There's 20 items there. The 20th, or in this case, the 19th, with a 0 starting number is 6765. So we did it right. And then if we wanted to go and do this all over again, we could loop, 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 which is kind of no fun if you do it more than a few times. Or I can just push the play button again and continue. And when I do my continue, there's my result. So that's interactive debugging. So we learned a little bit of a bonus thing there as we were running through our working with lists of other stuff. All right. So we're going to stop right there, and we're going to go on in a little bit and talk about classes and objects. We're learning about C# 101. I think we've reached your favorite part.
We have object-oriented programming.
Nerds.
So this is the, so this is the time in your C# curriculum where you know you've made it. Now we get into the serious bits of C#. We're going to go over inheritance. We're going to go over objects. It's going to be great.
Awesome. Cool. So what I'm going to do is I've got my Exploring Object-Oriented Programming documentation up, and I'm going to, again, snap that off to one side. And we just finished our Fibonacci sequence. You could go and check that video if you want to. But I think we should just start from scratch. It's File, New, Project time right now, don't you think?
Let's do it, yeah.
Okay. So in Visual Studio, I'm going to say File, New, Project, and we're going to basically get rid of the previous one and start from scratch with another console app. So I'm going to make a console app, and we'll call it My Bank, I don't know, My Super Bank, right? We're going to make a new bank. And we'll hit Create. And then it's going to ask us if we want to save our old project. I don't care about that old project. We're going to toss that. We're starting from scratch. And we're back at Hello World. And the only thing that's changed is that it's My Super Bank, which is awesome. So
Better
we're
than
back
other
to Hello.
banks.
It's way better. Other banks suck. Our bank is the best bank. So what we want to do is think about object-oriented programming, right? And make a bank account. Now, what is object-oriented programming? What are objects and why are we orienting around them?
So objects are basically a way that all computer languages can learn how to learn how to mimic the real world. So in the real world, we organize a lot of information in various different ways. With object-oriented programming, we can say, hey, a person can have a name and an address and a hair color and that kind of thing. So people can have different properties, and it's just a way of grouping all information.
Right. I mean, we're orienting around objects. Like I can make a mouse object or a bank object, or and then when you talk about inheritance, we can have animals, and there are types of animals.
Yeah.
Right? And you can have a hierarchy, just like you have in reality.
Yeah, definitely.
So it's intended, I think, to be intuitive of some kind. So hopefully you won't find this too intimidating. Okay. So according to this tutorial, they want us to make a bank account. So then presumably we need a bank account, and it has certain requirements. What is this?
Right, so it
List
looks
of
like we need
requirements.
a 10-digit number that will uniquely identify the bank account. So this is one of the properties that will be in our bank account. It needs a string for the name or the name of its owners. It needs a balance. It needs to be able to accept deposits and withdrawals. So
Right.
these are, I guess, capabilities that it'll be
Yeah.
able to have. So they're not like a single unit of data. It's actually like a function that
That's a
will be
good point.
attached to this.
These first three are really characteristics or properties.
Right.
And these seem like methods or things that it can do, verbs. And then what are these two? These are kind of like rules.
Yeah, so it looks like the initial balance must be positive. So I guess when we're creating that balance number, we need to make sure that it's above 0. And withdrawals cannot result in a negative balance, which makes a lot of sense. That would not be a good bank system.
And this is very typical of object orientation, right? There's going to be some properties, like things, cars have color and banks have balances. Then there are the stuff it can do. Cars can drive, banks can take deposits. And then there's rules that you're doing those things, don't exceed this speed, don't crash the car. So we need to go and start thinking about our bank account type.
Yeah, so all lots of things that sort of describe the behavior and the design of what this object will look like.
Now, so far, we've been putting everything in program.cs. I feel like bank account maybe should go in another file.
Yeah, let's make a bank account class.
Now, on the right-hand side of Visual Studio here, there are these little flyout tabs. And when you click on them, different things fly out, like I can go to GitHub or whatnot. And I'm going to click on Solution Explorer and push this little pin. And this is going to let me see the files inside of my program. I have one called program.cs. And in fact, I can open it up and see my main. So that's actually not a file, is it? That's showing me the structure of my
Yeah, so it'll list out the classes that you have within that file as well as the methods in each of those classes.
So I'm going to right-click using the right mouse button and say Add. I could say New Item and get a whole list of item. Or I can say Add Class.
Let's do that one.
All right.
Add a
let's do
class.
Add Class. So I can say Add Bank Account. Now this might be scary, but this is just a list of all the great stuff that you can add in the future. We're just going to say Add Bank Account. That seems like a fair thing to do. And you look, it went into another file, and it has the same namespace, that same bucket.
Right.
All right. So look at this. We could copy paste, or I could type in public, because it's available to the public, string number.
Yeah.
And number is only gettable. This is called a property. I can get numbers, but I can't, like, once it's been assigned, I can't set the number.
Right.
But I don't want to keep typing that. That's tedious. That's
Okay.
tedious. I'm going to do this. Remember how before we typed for each and hit tab? Check this out. Prop, tab, tab,
Ooh, a code snippet.
code snippets, tab, tab,
Okay.
owner, enter, enter, prop, tab, tab, decimal, tab, tab, balance, enter, enter. Look at that.
Man.
Not
Or you
great?
could type it the old-fashioned way, but
Oh, nonsense. I want the computer to do the work.
tab is your friend.
Tab is a great thing to remember. Anytime you're in Visual Studio, tabbing will probably get you something, and worst case scenario, it gets you white space.
Right.
Okay, and then let's grab these two functions,
Right.
and then maybe you can talk
So
about
these were
those.
sort of the actions that were listed out in the requirements. So it needed to accept deposits and make withdrawals as well. So instead of properties, these are going to be methods. Everything that you see in this class, these properties and these methods, all of these are members that are just one part of this class.
Right, and when we made them all public, 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 that means that other applications and other classes within our application can look at those and talk to those.
Yeah.
If they were private, they would basically be secret just to bank account, and no one else would know about them.
So right now your class doesn't have public in front of it, and we could
Ooh.
also change that
That's a good
accessibility
point.
level.
That's a very good point. And then you see, look on the right here, you're going to get used to seeing these symbols as you move through Visual Studio and C#. The number and the owner and the balance, you can see their types and their names. And that's kind of a nice view of what's going on. All right, let's go back over here and see what's going on. We've got our members and our properties and our methods. To open a new account, we need to make one. We need to construct a bank account.
Right. So far we've designed what a bank account should look like and different properties it should have, but we haven't actually made one.
Right. So if someone were going to make a bank account, they would have to go and say, bank account, that's called a constructor. Now I could make a constructor that doesn't really do anything, but you can't open a bank account with nothing.
Yeah, like you at least need a number, right?
You
That's
need
one
a
of the
name, you need
requirements.
an amount, exactly.
And since the number doesn't have a setter, we should probably create it at
So let
the
me think.
constructor.
Yeah, so then let me think here. We got what? We have the name of the person.
Yeah, that'll be one of the input things.
Okay, and then we were doing data types before, integers and longs, decimals. What is the right number for a bank account? I mean, I have pennies, but I also have fractions of pennies. It's not an int.
Interesting. So we declared the number up at the top as a string, right?
No, that's the number. That's a great point, actually. This number is the bank account number, which might have
Right.
letters in it. So it's actually a string.
Oh.
But the balance is a decimal. So why don't we make the initial balance
Oh, that's right.
a decimal as well?
Because you need to have cents. So it
Yes,
needs to
you
have two
to
decimal
you have to have
places.
cents or whatever your fractional currency is.
Right.
Okay, so here's where it gets interesting. Those are arguments. How do I get those into these properties, right? I basically need to tell it about this object that I'm in, this object, the one that I'm working on.
Right. Right. So the parameters are being input into the constructor, but nothing's actually been assigned.
Right. And this is where I think object-oriented programming gets confusing to people, because this is a description of what a bank account could be like, but it isn't a bank account. It's like a template for a bank account or a description of a
Good
bank
point.
account.
Or like a form. Like we require all
Yeah.
of these things, but we haven't filled out the form yet.
It is a form that we're filling out. That's a great way to look at it. So these are the form fields, and I need to make sure that this information in the constructor, when I make the form for the first time, goes into the form fields of whatever this current account that we're on is.
Yeah.
So I'll say this. The owner of this account will be the name that we just passed in, and then this balance will be the initial balance. And after I've done that, that goes away, and that's really it's thrown away because I copied it into here. Does that make sense?
Yeah.
But look at this. It says you don't even need to say this. I like to say this because it means this object, not that object.
Okay.
But they're saying it doesn't really matter. It's kind of like var. It's one of those things where if you like the way it looks, use it. And if you don't, that's cool too.
Cool.
Okay. That's not the awesomest bank account, but at least I could make it and test it. So how would we do that? What would be the bank account hello world?
Yeah, how do we call this? So now that we have an object, when we have the template for it and everything, we need to actually input data. So let's call this, how about in our program?
Okay, so back over
That's
in
yes.
hello world.
Yeah, and we can initialize, remember main is like the main entry point for any application. So we can, when we run this application, we'll just create one bank account. That's
Okay.
the goal.
So var account
Yeah.
equals, and then we knew something. And we've never done this before, have we? Because we've
No,
always
we
been
haven't.
saying like 0.
Yeah.
We've
something
never
like that.
knew something. Some people call it like newing it up, like as if newing is a verb.
Interesting.
Yeah, you ever heard that? You ever knew up something?
New it up.
So let's new up
I'll have to
a
use that.
bank account. And then when we pass in, we'll say Kendra's money. And look at that. It actually gave you the shape of that. It gave you the help. And if I hit comma,
Because we're calling the constructor right
Yeah,
now
look.
that we just defined as needing the parameters of a string and a decimal.
right. And that's why you use a Visual Studio. If I use Notepad, I could do this, but I wouldn't get all of this help. I wouldn't get all the spell checking, right?
Yeah.
So Kendra has $1,000.
Maybe
Nice.
just add a few zeros to that.
Congratulations,
That'd be
$10,000.
excellent.
Very nicely done. And then let's do a console.writeLine, just like before, except this hello world would be different. This is the hello bank account world, isn't
Right.
it? So let's go and do our string. And I'm going to put that string interpolation thing there, right? That's important.
Yeah.
So we'll say account, and then something was created for Kendra with some money. Okay, so let's go and get or dig our information out of our object there. So what is it? Account dot account dot. See how I didn't get my IntelliSense unless I spelled it right.
Right.
So account number was created for account owner with account balance. Ooh, that's cool. Does that look like a decent banking hello world?
Yeah, I think we
All right.
can call that.
Let's give that a try and see what happens. Ah, look at
Account
that.
blank.
Account blank was created for Kendra with $10,000. So in the next video, we're going to figure out what a good account number would be, how to make one, because we're going to have lots of different accounts, and we never even figured that part out. We only did names
Right.
and balances. So that's just us defining an object and making an object. Hi, we're learning C# 101. We've been making a little bank. We're making our tiny bank, and we're using object-oriented programming. So far, our tiny bank doesn't do a lot, I'm afraid. Right now, it just prints out the account number for an owner and the balance. And actually, when we tried to print out the account number, we didn't even get that far.
Oh no,
Yeah,
it just
so
has a blank where
account
account
blank.
was something.
Right. So let's go figure out what's going on there. So account number is a string, and we never really did anything with it.
Yeah, we didn't set that string.
Right. We didn't initialize or start up that account number, and we're following this tutorial up on the Microsoft Docs, and they're suggesting a way to go and do 10-digit numbers by seeding it or starting it with an initial number. And there's lots of ways to do this. So if you're a super advanced person who's watching this 101 video, you might want to ask yourself why you're doing that. But you might also want to understand that there's a lot of complexity. We aren't making an actual bank. We're making a fun simulated bank. So,
Right.
so do bear with us. But what we're going to do is we're going to have this account number seed, but it's private. We don't want anyone to know about that, right?
Right.
It's private in that people won't be able to see it outside of the bank account, right?
Right. So this is only going to be used inside this class and
It's
not
internal.
external.
It's like
Yeah.
it's an internal thing, exactly. It's an integer, and it's static, which means it's being shared across all of our different instances of bank accounts. So every bank account has the same seed.
Okay.
So we'll see if that's a good thing or not. There's lots of ways to potentially solve this problem. But the idea would be in the constructor of this bank account, we're going to go and set the bank account number to that seed, and then we're going to increment it so that the next bank account has a different bank account number. Again, not perfect, not the idealized way to do this, but for the purposes of our little single instance, single threaded thing, this will work great. Each new account gets a different account number. Does that make sense?
Yeah.
So do you think that'll work? We put that, turn it into a string. Notice that we say int toString, and we store it in here because sometimes account numbers have letters in them.
Right.
There we go.
Yay! Now I have an account number
Now
for
you
my
have money.
bank account.
Okay. You're not a very intuitive number, I'm afraid. The simplest possible number, but the next one would be 91 or 92.
Right.
Okay. Cool. So here's where it gets interesting. They're suggesting that in order to create deposits and withdrawals, we need a history of transactions.
Ooh.
So we should really make another class.
Right, for all those major purchases I've been making. Okay.
Do you like to have one file per class when you make your programs?
I do. I tend to try to do that, unless that class is only being used by the class that shares its file. It's just, again, all of this is organizational preferences. So
you don't have to have all these things in different files, right? Just like if you wrote the Great American Novel, you could have the entire thing in one Word file.
Ooh,
or,
risky.
or every paragraph could get its own Word doc, which would also be weird.
Ooh, cumbersome.
Exactly. The same thing applies with programming. So you get to decide, but I think a good rule of thumb is each class can get its own thing. So we'll say transaction. Cool. And I'm going to copy that one
Yeah,
to
it's kind of long.
save a little time. And we'll notice that that's public as well. It's got, let me think, every transaction has an amount and a date and some notes about the transaction. And this is a real common pattern, isn't it? This constructor where you pass things in and then you basically plug them in. You're passing them left hand, right hand, left hand, right
Yeah,
hand.
so you set all of your properties.
Okay. Now I've got a transaction and I've got a bank account, but I mean, they don't really know about each other. There's no list of transaction managed there. I'm not sure what we should do.
How are these supposed to interact? So I guess I'd assume that one bank account has many different transactions associated with it.
That's fair. And we've been talking about lists of stuff. We did lists of strings and lists of ints, but we never really made a list of a type of our own making.
Right. So should we make a list of transactions?
Let us
here?
do that. So let's make it private for now. We could decide later maybe if we'll make it public or not, but I'll say list of transaction. Look at that. And then we'll just have it be like maybe all the transactions. All transactions. And then this is really interesting. If we just did that, do we really have a list there? Or do we just have a null or a nothing list? We have the box or the space set aside for a list in the future. But we don't really have a list, you see?
Right. Because it hasn't been, I guess the space hasn't been found for it.
Yeah.
Like the variable name is claimed.
Yeah, very well
So you
said.
can't reuse all transactions, but they're adding the new.
That is a great way to put it. We blocked out, we put our thumb on the chess piece and said, that's my name, all transactions. I'll make one of those later of some size. Now here, we've got an empty list of transactions. That's a little bit different. And that is working just fine because we already have a system.collections.generic at the top there. So if I had a list of transactions, do I keep a running balance or do I calculate that balance from my list of transactions?
I think you'd want to keep a running balance. What are you thinking?
Well, so right now we've been keeping it in a place called balance, which has been the kind of the initial balance, right?
Right.
But you're right. Like it does make more sense that every time someone asks for the balance, we need to check, right?
Yeah.
So this looks and feels like a decimal property, but we can calculate it, can't we? We can go like this, and that getter becomes a bit of behavior. It becomes a function of sorts, doesn't it? So I can go and get the balance. So let's see what we could do. We could start with an initial balance of 0. So let's assume that everyone starts with $0. That seems fair. And then remember our friend the for each. I love this. And I just did look at that, I love that. For each tab. For all the transactions, because it's a list, I get that for free. Balance. Now remember before we did balance equals balance plus item dot. whatever.
Right. Is there an easier way to write all that out?
Yeah, I found out that you can go like this. So balance equals balance plus item amount. The same thing like that.
So those two lines, that's the same statement basically?
Yeah, they are equivalent to each other. Balance equals itself plus. You're basically adding two. And then, of course, you can guess that you can subtract as well.
Ooh.
These are what like you mentioned this. This is why you like C# so much, right? It's syntactic sugar.
Yeah, and it's not that you needed to know what plus equals means immediately. You can kind of discover it and simplify your code as you go.
And you know, I tell you, you and I have both been doing C# for a very long time, and I discovered those things, I would probably say, every week or so.
Oh yeah, I'm always discovering new stuff.
And there's nothing wrong with that. I mean, they always say when you learn things like Go or chess, it's like a minute to learn, a lifetime to master.
Oh, sure.
I am learning new bits of fun syntactic sugar, or like, oh, but you could try like this and it looks more like a poem. Right?
Yes, we're always aiming for poem status with our code.
Yes, if it reads like a haiku, then you've done it correctly. So here in the balance, we go and we list all the transactions and we return it. And then now this balance can go away because the initial balance in this case was already 0. So initial balance can disappear because everybody starts with 0. And then we just need some transactions. So let's just see if that still runs. Uh-oh.
It looks like you got an error. So we're actually going to fix that. There's some object-oriented problems that we'll re-architect a bit in the next video. So in our last video, we actually introduced an exception into our code. Let's take a closer look at that.
So I went and tried to compile, and I'm being told that bank account balance cannot be assigned to. It's read-only.
Right.
Yeah, I thought it was clever because I made balance a getter, but the initial balance, it won't let me set it.
Right. So now that we're actually thinking of this balance as something that's directly related to a transaction, we shouldn't actually just give people an initial balance. Like, we don't want to give away free money, right?
I see. The initial balance is the first transaction.
Right. So that should be a deposit.
Okay, cool. Well, we never wrote deposit, though.
Yeah. Why don't we go ahead and do that?
Okay, so this dot balance, initial balance, that's going to have to go away. And then we need to go and write how to make a deposit. And, you know, there was a list of rules about certain things, like I shouldn't be able to deposit negative money.
Right.
Stuff like that. So let's go back and look at our instructions here. And they've given us that code. So to save time, I'll copy that, and then we can walk through it if that's okay.
Sounds good.
So all I'm doing is I'm selecting make deposit and make withdrawal and copying over the top of them. Now, it might look like a lot of code, but let's just zoom out just a smidge, and let's figure this out, because this actually is cool because it puts all the things we've learned together, right? Ifs and lists and all this stuff. So what's going on here?
I do see something a little new.
Yeah, so
those
hang
are
on.
those exceptions?
Yeah, so
okay, we'll get to that.
Well, if amount is less than 0, right? If I try to deposit negative dollars, what's a throw? That's totally new. So throw new argument. We know what arguments are. These are arguments. Out of range exception. That's exceptional.
Yeah. So it looks like it's checking to make sure that the amount needs to be, you know, above 0, or at least equal. Yeah, above 0.
I guess you could deposit 0. That's kind of weird, but then we could figure that out
I
during
don't think we should bother with
during
it.
our code review. So
Let's do at least some amount of money.
So if it's less than 0, then it's negative, and we throw an exception. And an exception is a big deal, right? It's exceptional. It stops the program
Right.
if you don't catch it and look at it. You know, if I tried to go to a real bank, and actually, this is a good question for you. As an object-oriented programmer, I go and try to model reality. If I were to go and cash a check for negative dollars or deposit a check for negative dollars, wouldn't that kick off some kind of business process at the bank where they would be like,
Probably.
this is not a thing.
Like, decline, did we owe you money? Why don't we just write you a check? Why do you need a negative check? Checks don't work that way.
Questions will be asked.
Yeah.
So that's an exceptional moment.
Yes.
And that is what an exception should do. You throw exceptions when something's completely out there. This is an interesting one down here in make withdrawal. Like, what if the balance that you have minus the amount you want to withdraw would make your number of your balance go under 0?
That's an overdraft.
Right. That's an
Not
interesting
good.
one. That's not an argument out of range. That is, in fact, an invalid operation. You can't take that money.
Right.
And then look, if you throw that, does it let you continue? Does the next line run? It does not. They'll stop everything. When an exception occurs, it's like, and this function is over. All
right.
things stop running at this point.
So we don't simply exit the if statement, because that's sort of what it looks like. But since that throw is there, it'll actually exit the program and not try to.
Exactly. It'll exit the function unless we caught it higher up, and then worst case scenario, it'll go all the way up and exit the entire program. But the intention is that it'll exactly stop the running of this particular method. So if we look at these without the ifs, it looks very simple. Make deposit, new transaction. Add a deposit. Make withdrawal, new transaction. Negative amount,
Yeah.
add a withdrawal. And then you add the guards around it, and it becomes a little bit more kind of fleshed out, a little bit more.
Yeah. Maybe more secure and enforcing the kind of pattern that we want people to use with the system.
Exactly. So then the question is, what would bank accounts constructor, remember before I was just shoving the balance in there directly, what would that look like in this new world where I have a deposit?
Right. Well, instead of just assigning the balance to a static number, we should actually probably review all transactions to see what the balance is.
Right. So we've done that here where we say for each item, and that's a balance. We started at 0. That means that an initial balance rather, should be itself a deposit. So I will make a deposit of the initial balance. We'll start it today. This is kind of cool. We haven't done dates yet.
I like that it needs a
time.
date. That makes sense.
Well, you can say datetime.now, right? And then no one passed in a memo, so I'm just going to say initial balance, starting balance. So then I would think we call make deposit. It's going to add a new transaction to the list, and then we would expect that your balance would be, what did we give you, $10,000?
Yeah, so I'm going to lose that probably. Or I could deposit that in the bank account.
Right, but see, look, when you construct the bank account, that 10,000, here's our constructor. The deposit of the initial balance is 10,000, so you should not lose that.
Okay.
Then when we check
Well,
the
I have
result,
to give it to the bank.
Oh, you do
is
have to
what I'm
give-
saying.
yeah,
The
you
bank's
do.
not giving it to me anymore.
No, that's a good point. No free money in our
Dang
our
it.
tiny bank. There we go. Look, so now we're back where we were, but it's more object oriented, and that's really interesting. So then, now we can start simulating our bank. Okay, so let's do this. Let's take a little bit of money out and just see what the difference is. So what? Account dot make withdrawal. What do you want to buy?
Ooh, let's buy like a hammock.
How much does a hammock cost? $120.
Yeah, that's like a good hammock
It's a high
on
quality,
Amazon. It's
fancy
good.
hammock. Okay, datetime.now, hammock. Okay, and then we're going to go in console.writeLine, account.balance. Remember that balance is calculated from our list of transactions. Let's see if this works.
Right.
Look at that.
There we go. So my withdrawal was calculated, and now it's output as my balance, which is now $120 less than what I had.
Absolutely. So let's take a little bit of a break here, and then we'll come back and let's actually print out the entire ledger and make it look like a real checkbook or a real bank account.
Like for all my transactions.
All your transactions.
All right.
Let's do it.
In our last video, we basically completed our app. We have transactions, withdrawals, deposits, all of that. So let's throw in a few things that it's not expecting.
Okay, so right now we bought you a hammock. So let's go and maybe make a deposit of negative $300 because you can't deposit negative money, right?
Right, so this shouldn't be able to work.
I'm pretty sure this would be a bad thing. Stealing, I don't know what we call
Oh
that.
my goodness.
Yeah. Let's see what happens if we do that.
And what did you use to run it again?
I've been pressing Control F5. Now this is a great point that you bring up. You can always push this button, but that button starts a debug session, and we talked briefly about debugging. And if I don't want to run the debugger, I can just say start without debugging. So it's been a habit of mine to press Control F5.
Gotcha.
F5 for debugging, Control F5 to not. Either one works, whatever makes you happy.
And what happened? Oh my goodness.
Okay.
So
Amount of deposit must be positive, parameter amount. So it's telling me a lot of information. It's even telling me the line number. Look at that. Bank account line 44. Let's have a look at that. And here's a pro tip. You taught me this. Control G
Jump to line number 44.
44. Whoop, whoop. Look at that. So it did not make it there because you can't put in negative money. Not cool. Amount of deposit must be positive. So that's cool. Now it stopped the program. Like it's done. We're not banking anymore. So that's problematic.
Right.
So at this point, what can we do about that? Well, we could possibly catch that, and we can go back over here and learn about this. If I wanted to go and grab some code, I'm going to take this code from our document that we're doing. We're in here in the Exploring Object-Oriented Programming, right? So I'm going to copy that little chunk of code there and put it here. We'll go ahead and copy overstealing. There we go. So we're going to make a bank account with negative money, and then we can actually try. This is like, we're going to try. I mean, it could work, right? You never know.
Right. So it's a way of sort of testing your code, and then if something doesn't work out, we do actually catch the exceptions and print them to the console.
Exactly. Now, we do acknowledge that this is not testing. I mean, it's technically testing, but as someone who owns testing for Visual
there
Studio,
are better ways to test.
and we will show those better ways in videos later on. So bear with us. We will show you some great fun ways to test.
But this is good when you're just trying to figure out what will break, if
Right.
it breaks at the right time, all of that.
But a good thing to test is later on, I'm going to go and maybe do another withdrawal of $50 for an Xbox game.
Ooh.
And then output the balance. If this really stopped, then I would never get my Xbox game,
Right.
right? And if this shut us down, if this was such a major bug, but if it's simply something that was a guard, it's almost like when you're bowling. This is the little things that keep me from going in the gutter.
Oh yeah, like a guardrail.
Yeah,
Okay.
exactly. So exceptions as guardrails. Okay. So there's your initial $10,000.
Yeah.
There's your hammock. Here's it preventing me from making a new account with negative money. And there's the balance after my Xbox games.
purchase. Yeah.
Okay? So the exception, if you catch it, like you're throwing yourself on the grenade, you did not actually blow up your entire program. So that's kind of cool.
So it's sort of a way of, it'll still give you feedback. So you can still write in your catch statement like console.out line
Exactly.
and figure out what exception message to outprint, but it lets you continue with the program.
Exactly. So we'll take that and I'll put that elsewhere for now. We'll just move that down a little bit. And they've given us another one too to check for negative balances. So I've got a couple of fun things where I could take out like $75,000. These are tests, and they're only tests because I put a little comment there. We haven't seen comments yet. But if I go // hey, this is a comment. Next couple of videos, a little later on, we'll go and test those for real. But you know what I'm realizing as I was trying to figure out what was happening in our app? Did you notice that I was like, that's an Xbox game. Trust me. This is a hammock.
Yeah, it's a little unclear what transactions were happening.
This is not pretty at all. I think we need to go and log all of our transactions. So why don't we do that, okay? So let's walk through that. At the end of buying the hammock and the Xbox game, I'm just going to make some space. White space doesn't matter, right?
Right.
I could go and spin through that stuff here, but from an object-oriented perspective, whose responsibility is it to give me the account history?
Ooh, probably the account itself?
Well, and that's a good question, right? Like, yes, but it depends. And this is where you, the reader, could decide, well, I don't know. Like if I go to a library and get a book, does the library check out the book? Or does the book check out itself? I don't know.
How automated is your library?
There are consultants that make their money answering those questions. Maybe you one day can be one of those consultants, people who are watching. I know that arguments can be made in both ways, can't they?
Definitely.
So let's do this. Let's do what you said, and let's make the bank account in charge of that.
Yes. Okay.
Awesome. You're winning.
So we need to print out some kind of transaction history
Okay.
thing.
So let's make a thing. Notice, of course, we talked about void does nothing. Our function is going to return a string. That's going to describe what's
So
going
we
on.
can just output that string to the console.
Yeah,
And
'cause
that'll be our
We
account
live in
history.
console world right now.
Sounds good.
Okay, so get account history. I assume it's for this account, so we don't need to have any parameters, right? It's the account that we're currently working with, this account.
Yeah, it'll be like the list of transactions with this specific account.
Now, a lot of times we've been doing strings like this, where I say $ whatever, but someone told me that if you make lots and lots and lots of strings, that there's a better way to do that. And that's called a
Yeah.
string builder. So we're going to make a report. Let's do this report. And then where is string builder located? If I say new string builder,
Will it find it?
did it find string builder automatically? Is that Visual Studio found? Oh, it's in system.txt.
Oh,
So
okay.
it was already there.
So we have the namespace imported. Cool.
That's cool. All right. And then we'll say report. And this is interesting. String builder for building strings. It has like append line. We'll add a line. And then it takes strings. So what do we want to put in there? What do you think?
How about the date, the amount, and the note?
Okay, so let's go date, amount, and then the note. Those are kind of the properties, the characteristics. And this is a fun trick. You could like do it like this, right? Like I could go like space,
You're
space,
gonna
space,
just
space,
add
space,
a bunch
space,
of white space in
Yeah.
between to sort of make it like a column.
Yeah, or I could do this. That's a tab.
Ah.
Isn't that funny?
Yeah, so this will make our columns a little bit more evenly spaced,
Yeah,
right?
exactly. I think amount has one M.
I like it.
Excellent. So, lots of different ways to do this. And then our friend, the for each. So for each item, where did we put our transactions?
I think they were in an all transactions
Okay.
list of
Yep.
type
That was right.
transaction. Okay.
Cool. So for each item, or in this case, each transaction, then the report's going to need a new line, I think.
Right, so this will be like the first row in the table that we're outputting,
Yeah.
right?
Okay. Yeah. So we're
So
making a
date,
table.
amount, and notes were sort of the header of the table.
Let's put a comment there. Header. Good idea.
Okay.
Okay.
And these will be
Report
rows.
rows. Yeah, go report rows. Cool rows. Oop. All right. Now, this would be a place to maybe do some of that string fun with the $ there. So what do we have? We have an item, which is a transaction. Now, this is
The
interesting.
first one was date.
Date. And let's say, well, I think we add a tab, because we'll have a tab for these as well.
Makes sense to separate each of them. And the next one we wanted was the amount,
Yep, amount. Okay, and then a tab.
and then any notes that they had on that transaction.
Okay, item, that's like Xbox game or whatever.
Yeah, I think the only one we added so far was the deposit. Cool.
Okay, cool. And then let's return that string builder, and I think we put string builder in report. So return report. Remember our method returns a string? It's a report, but hey, we made a string builder,
Oh, not a string.
not a string. How do we get a string out of there?
Oh, it looks like there's a toString method
Yeah,
on the string builder type. So we
turns
can
out
call that.
everything in C# has a toString. So no matter what
very
you're doing, you can get a toString 99% of the time or more. So there's our toString. I don't know if this is going to work perfectly because I don't know about that date. I haven't said how that date's going to look, but let's go and see what that's going to look like. So back over here, let's go and say console.writeLine account dot, and then where's our get account history?
There we go.
Now we're talking. And then I'm going to put that inside of a function because that's a method within WriteLine. All right, and that's good.
So that single write line should output a whole table.
If we did it right, I think we should get a nice table.
Cool.
If we did it wrong, we should just stop recording now and just give up and quit our jobs.
Let's try it out.
All right, crossing fingers.
Okay.
Okay.
So it looks like it has a date.
It's a little bit shifted off to the side.
Yeah. Maybe we should add more tabs.
Well, there's a couple ways we can do that because I don't know if I need all that detail. Like I've
Right.
got dates and stuff. I'm also going to comment out these exceptions because they are stressing me out. So what I'm going to do is I'm going to get rid of these balances just for cleanliness' sake.
Sounds good.
I'm going to go down here and then I'm going to do a trick that you showed me as well.
Oh, comment
you
out
go-
the entire
yeah.
block.
You know it, right? You know what's up.
Control K, Control C, I
Yeah,
think.
see, you know the
but
exact.
it's also in the.
There it is.
There you
Control K,
go.
Control C. Boom. That way we won't. So we've commented it. We keep our code. We'll just worry about it in another video. Okay.
Nice.
So check this out. I'm going to get back over to get account history. I could click there, or I could right click, go to definition. Loving it. Okay, remember that date? I can hit dot. There's other ways to express that. Remember how we said everything has a to-string? Well, dates have like to short date string or to short time or whatever. So depending on what language you speak and where you are located in the world, that might come out in Russian or in French or whatever.
Oh, right.
The way that you want it, and you want that to be specific to your location. So I just said, let's do that date as a short date string. Let's see if that makes it better. Look at that.
Nice looking.
Huh?
Oh,
Only thing we
great.
could do to make it better would be put like a $sign or a British pound or whatever that we're doing. But I
Right.
think that's pretty sweet, and we have achieved object orientation at our tiny bank.
I love it.
So hopefully you have enjoyed playing with this as well. If you have gotten stuck at all, you can go ahead and look at the source for the tutorial in the GitHub repo. We'll make sure to include links for that in the descriptions, and you can find all of that at docs.microsoft.com. This is the end of the C# 101 tutorial list. You can go ahead and check out our .NET 101 and our ASP.NET 101 videos as well. See you soon.
Bye.